such as forests, watersheds, and soil ecosystems into urban planning to support functions like water management, habitat creation, and resource cycling. In a sense of landscape urbanism treats the city as a living ecosystem using ecological principles to guide design and moving beyond the traditional city versus nature divide. The image illustrates an example of landscape urbanism in Masdar City, which employs a comprehensive passive cooling system by blending traditional and modern design principles. Narrow shaded streets and contemporary interpretations of wind towers promotes natural ventilation and reduce reliance on mechanical air conditioning. These strategies, along with other green infrastructure and sustainable design practices, embody the principles of landscape urbanism and green infrastructure, significantly lowering ambient temperature and energy consumption compared to conventional urban models. So landscape urbanism is not merely a design philosophy, but a transformative urban strategy in response to the pressing challenges of climate change or urban inequality and aging infrastructure. By embracing the concept of resilient infrastructure, it redefines landscape as foundational system for resilience, rather than as ornamental elements as we all accustomed to in the modern days. Through this lens, landscape urbanism addresses a wide spectrum of urban challenges from flood management and food security to social equity and ecological renewal, positioning the landscape as a vital framework for sustainable urban futures. So we'll start here with the definition of conventional urban infrastructure. This is a basic system of essential services that support a city, region, or nation. Example of this are roads, sewers, bridges, landfills, dike dams, seawalls, and treatment plants. Conventional urban infrastructure is often characterized as monofunctional, which means it was built to do one thing and one thing only. It is often characterized as incompatible with its environmental context, and it's also prone to catastrophic failure. On the left is the LA River. This is an example of monofunctional infrastructure. This concrete trench replaced a natural flowing river in the city of LA. The Army Corps of Engineers constructed this channelization of the river in the mid-20th century, and this infrastructure basically takes water from point A to B. It does nothing else to its monofunctional. It has one function. This is also an example of infrastructure that is divorced from its environmental context. It's a concrete trench that is not interacting or communicating with its environment or its context. On the right is an image of the storm water tunnel that are being carved under the city of Washington, D.C. These tunnels are meant to convey storm water during storm events in the city to an adjacent wastewater treatment plant. So this is an example of how conventional urban infrastructure tends to take water from the city and make it essentially invisible to its citizen. In her essay, Infrastructure Ecologies, Hilary Brown lays out 4 principles for a post-industrial ecologically informed infrastructure. And then I think it is useful here to lay these out at the start of the discussion of what resilient or landscape infrastructure is. And she says that resilient infrastructure or landscape infrastructure is or are systems should be multi-purpose, interconnected, and synergistic. And infrastructure should work with natural processes. And then fourth, an infrastructure should improve social context and serve local constituencies. Also, infrastructure should be designed for resiliency to adapt to foreseeable changes brought by an unstable global climate. So you can start to imagine how all four of these principles are in almost indirect contrast to some of the observations, some of the challenges we just outlined for conventional infrastructure. There are numerous case studies and precedent studies of resilient infrastructure or landscape infrastructure worldwide for climate resiliency, some already implemented and others will be. For example, the Living Breakwaters project in New York, located off Staten Island's southern coast, right after, I think it was Sandy, I think, the storm that hit New York. So it was during the President Obama when he announced this project. So it's a nature-based design solution designed to reduce coastal erosion, mitigate storm surges, and restore marine biodiversity. It features a series of breakwaters with ecological enhancement like oyster reefs that dissipate wave energy, also foster habitat creation and improve water quality. It is interesting to mention that a single oyster can filter or remove up to 50 gallons of pollution from impaired or polluted water body per day. As a natural feeder, it filters out pollutants like nitrogen, phosphorus, sediments, and heavy metals. By consuming them or creating mucus-coated packets called pseudophases that sink to the bottom. This project integrates education and community engagement, showcasing the role of landscape infrastructure in building climate resilience. So the landscape architect here designed and engineered precast ecological concrete armor and tidal pool to reduce coastal erosion, mitigate storm surges, and restore marine biodiversity. This is another example. It's the Seattle Central Waterfront Project. It is a major redevelopment by Field of Operation. James Corner is the principal, aimed at revitalizing Seattle waterfront, enhancing public spaces, and promoting environmental sustainability. It integrates nature-based solution to address urban challenges like flood management, habitat restoration, and climate resilience. A key feature of the project is the protection of the baby salmon during migration and the resilient seawall design to prevent the sea from encroaching to the urban areas. So the design includes a protected tunnel with internal pockets that safeguard the salmon from the predators and provide a safe, nurturing habitat for them to feed and survive. This approach highlights how urban development can support both human and wildlife together. It also demonstrate the importance of the collaboration between landscape architects and marine ecologists. Another example, Wadi Hanifa is a prime example of resilience landscape infrastructure. It locates in Riyadh city. It's already constructed. It applies the principle of landscape urbanism and biomimicry through the integration of engineered biocells designed to treat point source pollution, aka or as known as black water or sewage, that once flowed untreated from Riyadh city into the Wadi, causing significant environmental damage and increasing health risk, particularly for the nearby neighborhoods. By harnessing natural processes for effective bioremediation, the project exemplifies the ecological design can finally restore and sustain urban environment. So this technique has demonstrated remarkable effectiveness in enhancing environmental quality and public health. It has significantly increased the biodiversity of the wadi or the valley, transforming it into one of the most stunning semi-arid oases in the world. These are some of the images. This transformation has also boosted real estate values in the surrounding neighborhoods and greatly improved the overall quality of life in the city. So this water, as you can see, it's 24/7 running water in the middle of the desert. Shockingly, it used to be sewage and heavy metal dumping in the valley, and they turn it in this stunning ecological solution. Built on a former industrial site, this case study, which is Hutun Park, was created for the 2010 Shanghai World Expo to demonstrate green technologies to the influx of visitors and remain as permanent public waterfront park. So the park was designed as a regenerative living organism that treats polluted river water, mitigates urban flooding, and increase habitat and biodiversity, while also celebrating the regional culture and beautifying the riverfront for public use. Oops. Hutun Park unfolds along the Hangpao River, I hope I pronounced it well, through several linear miles of natural and constructed wetlands that clean the polluted river water and encourage native fauna to return. Throughout the park, several reclaimed structures reveal the site's industrial past, while terraces planted with a variety of traditional crops give reference to the country's agriculture heritage. Urban heat island is another issue to be considered when we reimagine our cities, our neighborhoods, and small spaces where we socialize. I was honored to lead an NASA-funded project titled "Sustainable Community-Based Design Solutions Encountering Climate Change," a heat-related case study of the John F. Kennedy neighborhood in Oklahoma City. Landscape urbanism also deals with urban heat challenges as a whole. Extreme heat is, in fact, the dead list of all natural disasters in the United States, and its impacts are not evenly distributed across people and places. Historically underserved communities, particularly those with limited access to resources and green spaces, face significantly higher risk from extreme heat. The JFK neighborhood is one such affected area. Part of this disparity system from historic segregation policies that marginalize specifically African American communities, systematically placing heavy industrial land uses, unfortunately, within their neighborhoods, while denying access to basic needs such as home loans. So those people who live in these neighborhoods, they cannot even take a loan from bank just because they excuse that of these industry land uses that was actually forced to be within their neighborhoods. So the practice known as redlining, this kind of like racist act, has left lasting social, economic, and environmental consequences. In this study, we collaborated with the city of Oklahoma to examine the impact of extreme heat across Oklahoma City, with a special focus on underserved community like the JFK neighborhoods. Using
Dr.
several microclimate data collection tools and
Sorry,
analysis,
Doctor.
we generated heat maps. Sorry?
Oh, you have around 1 minute left to wrap your talk.
Okay.
Sorry.
Yeah, my apology. All right. So this is just an example of the what we did, and we used the sensors for that. This is another project. I'll just go through it quickly. In here, I was talking about the flooding issue in the GCC region, which is Gulf countries. And then this is what I proposed. It's like this is the study of the flooding issue in Jeddah city, and you can see the contrast between the need for public spaces slash the illogical paved concrete channels. And then I proposed this solution as a part of the thesis study when I was doing my master in Virginia Tech, and luckily I was awarded 3 awards. Among it was the American Society of Landscape Architecture. Basically, how to study the feasibility of turning these channels into green channels and create more or generate more open spaces. It's a system of harvesting water and reusing the water that's being flushed to the sea without even consideration for reuse. This type of project was inspiration for many people in Saudi, including city of Jeddah and others as well, as it becomes senior project for some of the students in KAU, where I got my bachelor degree. The image illustrates the vision of the developing a green channel to urban wadi in Riyadh. It's not the same function as for flooding, but it was grasping the same spirit of the that type of projects. I have two couple slides before I finish. So as we continue to advance our fields, we face both challenges and opportunities. Together, we will explore how to create urban environments that are not only more beautiful and livable, but also more resilient and sustainable in the face of rapidly changing climate. Here's one initiative that to build resilient future cities requires collaborative initiative and academic partnership that help shape policy, educate the public, and foster community engagement. Programs like this one called 100 Resilient City Initiative exemplify this approach by helping urban areas strengthen their capacity to withhold physical, social, and economic shocks. Through such collaboration, cities in develop holistic adaptive frameworks that address the complex challenges of the 21st century, from climate change and urban inadequate inequality to sustainable development and community resilience. And also, there's a need to build an academic program to teach students and prepare them to hold positions where they are educated about resiliency and the importance for that in future. This is one of the courses I developed here at Cal Poly, where I sent my student using sensors that we developed from scratch to test the water quality, and we come up with correlation between how the urban development really affect the pollution and the temperature of the water, and how it's the green also help to remediate this issue and ease the impact. Finally, the final thought I wish to leave you with this: Allah has blessed us with countless gifts, yet we often take them for granted. True gratitude is not expressed through words alone, but through our actions. By protecting and honoring these blessings, our time to do so is limited, and perhaps that is the essence of our test. Innovation is essential, and resilience lies at the heart of the true innovation. Thank you so much.
Okay, thank you, Dr. Bogis, for your inspiring presentation. All right, ladies and gentlemen, we will now open the question and answer session, which will consist of 3 questions from our on-site participants and from online participants. For on-site participants, please raise your hands and the committee will bring you the microphone. For online participants, you may write your questions in the Zoom chat or raise your virtual hand. Okay, please. Okay, Bu Dian Perwita. Good. Thank you, moderator, for the opportunities. Thank you very much, Dr. Moin Bugis, for your insightful and inspiring presentation on biomimicry and landscape urbanism from conventional to resilient strategies. Now I have one question. Dr. Bugis, could you elaborate on how biomimicry principles can be effectively integrated into urban infrastructure design in developing countries with limited resources? Thank you.
So, simply just like looking at these case studies I presented, all of them actually an example of how the designer was thinking of the natural processes or mimicking a functioning system in nature, or some of them a design that is inspired by how, for example, the oyster, the living breakwater in New York, how they use the oyster to be the intrinsic part of the solution, the ecological solution they provided, which like preventing from the surging waves as they planted as masses, but also at the same time they used it to treat the polluted water there. Funny thing is that they use also they harvest these oyster to and resell it in the nearby or adjacent restaurants. So it's like a win-win situation for everyone. Cheaper solution compared to like the heavy engineer solutions like building the sea walls, which cost a lot in building and also in construction and also in maintaining them. I hope I answer the question.
Okay, Budian, what do you think?
Okay, it's enough.
Okay, thank you very much, Dr. Bogis, for your response.
Thanks.
Okay, we
Thank you
move
so much.
to another questions from on-site or online participants.
Again, I apologize million times for the delay because of the technical issue.
Okay.
All right.
Okay, Dr. Bogis, well, I also have one question for you here. What tools or technologies are most useful in modeling or simulating biomimic? What is biomimicry?
The biomimicry.
Yeah, biomimicry urban system. The tools and or
What are the tools? So that's the innovation part. There's no like such a tool or like where like we follow steps. It's just takes human innovation to ponder and look at the nature and ecology and wildlife to learn from and try to bridge or draw similarities between the human built environment issues versus the nature environment issues and see connection between how it's solved in that context and how can we mimic something from ecology, and that's why it's called biomimicry. So we mimic something from nature. And it's a practice that's been like even used in different type of arts, like the martial arts, like in kung fu, for example. They inspired by different moves from animals. So these kind of intelligence has been practiced back in time. It seems like we just become spoiled by the technologies, and our cities becomes a problem more than sustainable and solving our issues. So we need to create more technologies just to solve an issue that created by another technology. So just I hope I answered the question.
Okay. Well, one more question left. Please, participant from online participant. Okay, from Faisal Nurdin. The question is, can you explain more system that should be multi-purpose, interconnected, synergistic? From Faisal Nurdin, Dr. Bogis.
I didn't get the question. Sorry. What was the question? Can you repeat it, please? I didn't hear the question. Sorry. It wasn't clear.
Okay, Dr. Bogis.
Yeah.
There is one question online here from Faisal Nurdin. The question is, can you explain more system that should be multi-purpose, interconnected, synergistic?
Synergistics. Okay. I
Okay.
think he's referring. Is he referring to one of the slides? Let's see. Can't remember which one was it. Are you referring to specific project or Faisal? Do you hear me? Can't see the questions. Is there a way of measuring the performance? Oh, okay, yeah. All right, I see the question now. So is there a way of measuring the performance of biomimicry in the term of synergy? That's a good question. So we need to differentiate between the term biomimicry. The biomimicry is just like the innovative way of looking at a problem, but to test the performance, of course, there are hundreds of tools right now available, and we are still capable of building our own sensors to monitor or test the performance. For example, like that class I taught last quarter here in Cal Poly, we literally developed the sensors to test the water pollution and the urban heat. We use also thermal drones to draw us the comparison between the data we're collecting from the ground, and by that we could link it toward how is the existing in some area of like green area adjacent to the water was a lot cooler and the water was more cleaner than the areas that is closer to the urban setting, which is like buildings. Simply next to the outlet coming from the urban setting to the lake, it wash as it rains. All the polluting comes from the cars, which is something you cannot spot. You can test it through the water, and from that, for example, agencies like EPA here, environmental protection agencies here, they have like policies to control these kind of issues, and they come up with something called green infrastructure or low impact development practices, which is like to capture these pollutions. And I hope I answered the question. Oh, sorry, there's a question before. Can you explain more system that should be multi-purpose, interconnected, and synergistic? So for example, the channel that I proposed for Jeddah, it acts first as it keeps the or preserve the same function of flooding control, but also it acts as a park, linear park, since there's an issue with open space per capita in Jeddah, Saudi. The recommendation by World Health Organization is like 10 square meter per person, while in Jeddah it is 2 square meter per person. And so having these concrete channels that occupy huge lands in Jeddah, it provide this access to basic amenities like parks. Is it interconnected? Yes, because it also connects green patches or green areas around the city. One of them is ecologically evolved riparian corridor, which is shockingly, there's like a 24/7 running stream South Jeddah, and people discover that place and they start to go, and that's because there's a water and surrounded by heavy vegetation, and that vegetation or that green corridor that ecologically evolved have attracted migrant birds, something you can't see in the city. And so such a infrastructure that I propose, like turning these green channels, can connect these green oases. So it acts like, we call it in green infrastructure theories as linkages. So it connects between patches. And it's really important, especially in arid regions where the green patches is really minimal. And it's important for migrant birds because they have ecological function to do when they travel between continents. And so having these green patches for rest area, for food, is really important. And that's one of the examples. I hope I answered that.
Okay, Faisal Nurdin, what do you think about the answers of Dr. Bogis?
You are welcome, Faisal.
Okay, thank you. All right,
You're
Dr. Bogis, thank you for your thoughtful and inspiring answers. Ladies and gentlemen, please give a warm round of applause for Dr. Moin Bogis joining
Thank you
us
so much.
virtually.
And my sincere apology for the delay.
Okay, now we invite Dr. Bogis and everyone in the hall to join a virtual photo sessions together. Kindly turn on your camera and smile for our documentation. Okay. All right. So thank you very much, Dr. Wilson.
Thank
Okay,
you.
everyone. We now start the photo session. 1, 2, 3, go. One more time. 1, 2, 3, go. Thank you, Dr. Moin Bugis, for your presentation today. Give
Thank
very
you so
big
much.
applause for him.
Thank you all. Really appreciate it.
All right, now our next keynote speakers will join us virtually from Malaysia. Please welcome Surveyor Dr. Wilson Rangga Anak Anthony Jiram, Deputy Dean for Research and Commercialization, Faculty of Built Environment, University Sarawak, University Malaysia Sarawak. He holds a PhD in real estate and has received multiple international awards, including the Gold Award at Malaysia Technology Expo 2025. Today, he will present Innovating Sustainable Construction, Predicting Green Building Practices in Kuching through the Theory of Planet Behavior. Let's welcome Dr. Wilson Rangga, joining us online from Malaysia. Hello, Dr. Wilson.
Hello, good morning, everyone. I'm still working on sharing the slide.
Okay, good morning, Dr. Wilson.
Good morning.
Morning. Okay, we are so happy to have you with us today at ICArUS 2025. We hope everything is going well in Kuching.
Yeah, everything is going well. Thank you.
Right.
Such
All
a
right.
good, sweet introductions.
Okay, before we begin, just a gentle reminder, Doctor, that you have 30 minutes for your presentation, followed by a short question and answer session. Thank you, Doctor. The screen is yours.
Sorry, I'm having a problem in sharing the slides. Sorry, how is it? Can the flow see my slide presentations?
Yes, Doctor, we can see your slides.
All right. Yeah, sorry for the delay. And good morning, everyone. Again, before I begin, let me first apologize. My slides may not be as fascinating as Dr. Muin earlier presentations, but I do hope my story this morning will bring a different kind of insight, one that looks at the human side of innovations and sustainability. Okay. All right. So it's truly a pleasure to be with all of you, delegates and fellow explorers of the built environment, both those sitting in the accounting hall and those joining us online. So this gathering reminds us that knowledge is stronger through collaborations. Sustainability is solo missions. It thrives when educators, industry leaders, and researchers come together to exchange ideas that can apply in our cities and communities. First, allow me to thank the organizers from the Architectural Engineering Department of Politeknik Negeri Pontianak for the warm welcome and the opportunity to speak at this remarkable conference, ICArUS 2035. The team's innovations in sustainable designs and material could not be more timely. Across Southeast Asia, construction is booming, increasing pressures on our environment, but growth also gives an opportunity to redefine how we build using innovations, not just as technology, but as responsibility. So every generation of architects and builders faces a different challenge. For ours, the challenge is clear. How do we build sustainably without compromising the future? These questions reflect morals and professional obligations. In Sarawak, where environmental richness meet urban expansions, sustainability isn't abstract. It's a day-to-day decisions that shapes the city future resilience. In my talk today, I'd like to take you on a journey that began in Kuching, Sarawak, where I work with a group of passionate students and professionals to understand why green building practices, though widely discussed, are still so slowly adopted. In order, the adoption is still slow in our local construction industry. So our research titled the behavioral intentions to adopt green building practices using the theory of planned behavior. It's not just about the data or models, it's about people, their belief, their motivations, and the story behind every decision to go green or not. Okay, let's start with a simple truth. The buildings we create shape the way of life, breathe, and interact. So yet, the construction industry remains one of the largest contributors to global carbon emissions. Almost 40% of all emissions come from the buildings, both in the constructions and operations. So buildings influence not only the climate, but the quality of life of those who inhabit them. Every design decision, from material choice to energy system, either adds to or alleviates our environmental footprint. Now, imagine it is like Kuching or Pontianak, where urbanization is accelerating, the roads expanding, housing projects multiply, and new commercial centers rise every year. It's progress, yes, but it also raises the questions. So can we sustain this pace without harming the environment sustain us? In Malaysia, initiative like ICArUS, the Malaysian's carbon reductions and environmental sustainability tools, and the construction industry transformations program are designed to help. But when we look at the local level, especially in Kuching, we saw a gap. So despite awareness of sustainability, the actual adoptions of green building practices remains modest. So many professionals know what sustainability is, but few are ready to change how they work. In Kuching, awareness has grown faster than action. So professionals understand the why, but they struggle with the how. That gap between intentions and implementations has become focus of our inquiry. And that, to me, is fascinating. Because technology alone cannot make a change. People do. We often talk about innovations in terms of materials, bamboo composites, recycles aggregates, geopolymer concrete, yeah, but innovations also live in human mind. Yeah, technological solutions succeed only when behavior aligns. The willingness to adopt a new system depend on mindset, not access alone. Yeah. Why do some professionals eagerly embrace green designs while others resist? Yeah, what makes one project manager champions in solar panels while others stick with the status quo? Yeah. To answer these questions, I turn to psychology. Yeah. Specifically, theory of planned behavior. Yeah. Theory of planned behavior, or TPB, proposed by Isaac Eisen. Yeah. A professor. Wait, how to move this one? Yeah, a professor of psychology, emeritus professor at University of Massachusetts Amherst. Yeah. So this theory helps us understand how decisions, understand the human decisions. It tells us our actions are guided by three key things. So the first key, yeah, is our attitude, yeah, what we personally believe about the behavior. Yeah. Second, the subjective norms, yeah, what people around us think we should do. And third, yeah, our perceived control, yeah, how easy or hard we think the actions will be. So these three dimensions explain why even the most environmentally aware individuals sometimes fails to implement green solutions. Yeah. Belief alone is not enough without social reinforcement and capability. Yeah. When I look at green construction through this lens, I realize it's not just about environmental awareness. Yeah. It's about mindset, influence, and confidence. Yeah. So we designed a study around this framework, yeah, to see what really drive the people behind the projects in Kuching. Yeah. We conducted a survey with 61 construction professionals, yeah, quantity survey that includes quantity surveyors, project managers, and consultants. Yeah. People who make daily decisions that affect budgets, materials, and design choices. So these are the unsung heroes of constructions. They decide what gets built, how it builds, and how sustainable it can be. So most had more than 5 years of experience, several years of experience, balancing the pressures of clients, contractors, and cost limitations. A group whose behavior truly shapes on the ground sustainability outcomes. We ask about their belief, their experiences, and their willingness to adopt green building practices. Using partial square structural equations modeling, or in simpler terms, a statistical method that let us see how ideas and behavior concepts, we map out the relationship between the attitudes, social pressures, knowledge, and intentions. So this analysis helped uncover which psychological factors had the greatest influence on intentions, revealing that the social environment, not just individual convictions, often dictates behavior. And the result tells a powerful story. First, what we discovered, social influence matters a lot. We found that subjective norms, the influence of peers, the client, and professional circles, these are the most powerful predictor of whether someone intends to adopt green practices. Professionals look to the peers for validations. When sustainability becomes expectations within teams or organizations, adoption increases naturally. If their colleagues value sustainability, if the organizations encourage it, yeah, or if clients demand it, yeah, they are much more likely to take actions. Yeah, it's a reminder that culture, not just policy, yeah, and that drive behavior. Yeah. Peer recognitions and client expectations creates a ripple effect, yeah, turning sustainability from an obligations into professionals' right. So second, knowledge makers. Yeah, those who understood green building standard materials and environmental impact felt more confident, yeah, to implement sustainable strategies. Yeah, where knowledge builds confidence and confidence build actions. And third, attitude. Yeah, while generally positive, yeah, it's isn't enough. Yeah. Many professionals agree that sustainability is important, yeah, but positive feelings don't always translate into real adoptions unless backed by capability and support. Yeah. This shows that moral agreement, yeah, must be matched with structural support, yeah, such resources, leaderships, endorsement, and policy clarity. Yeah. Yeah. Fourth, yeah, perceived behavioral control. Yeah. That sense of can I actually do this? Yeah, remain a challenge. Many participants cited high initial costs, yeah, limited access to green materials, yeah, and a lack of skilled labor. Yeah. This obstacle makes sustainability feel out of reach. Cost was the most frequently mentioned barrier, yeah, followed by limited supplier network, and inadequate training. Yeah. Many believe that sustainability was possible only for high budget projects. Okay. And what we discovered, yeah, and finally, yeah, policy and regulations. Yeah. Policy and regulations play a subtle but crucial role. Yeah. Clearer guidelines, government incentive, yeah, and consistent enforcement can make green construction not just a choice, but a norm. So in summary, yeah, in Kuching, people don't resist green building because they don't care. They hesitate because they don't feel fully supported socially, yeah, financially, or structurally. Okay, let me share a quick story. So during one of our interviews, a project managers from a medium-sized firms told me, yeah, Dr. Wilson, I want to go green, but clients don't ask for it. Uh, Suppliers don't stock it, and my team doesn't know how to do it efficiently. So that single comment stay with me. Yeah, it sum up the ecosystem of hesitations. He wasn't against sustainability. Yeah, that's far from it, but he was simply caught between aspirations and practicality. His voice echoes that of many others, yeah, people standing at the threshold of change, yeah, waiting for structures, yeah, that make sustainability achievable. And this is exactly where innovation must meet empathy. So we cannot just design better materials, we must also design better systems that make it easier for professionals to act on their good intentions. Okay, now let's connect this to the theme of ICArUS 2025, Innovations in Sustainable Design Materials. Yeah? Innovations isn't only about new materials or cutting-edge technology. It's also about changing behavior and reimagining collaborations. Yeah? When we understand the behavioral patterns that shapes decisions, we can unlock the true potentials of innovations. Yeah, we can create training programs that build confidence In using green materials, we can develop incentive that make sustainability economical viable, and we can promote design thinking that places environmental stewardships at the core of every blueprint. Behavioral insight give directions to innovations, guiding where educations, investment, and design can have the most lasting impact. In the context of Borneo, with its rich biodiversity and unique cultural identity, innovations must also mean localizations. We cannot import a one-size-fits-all models from elsewhere. So instead, we should merge modern methods with traditional wisdom. Bamboo, timber composite, passive cooling, and community design principles. Because sometimes innovation is not about discovering something new. It's about rediscovering what we already know works in harmony with nature. So, where do we go from here? Our study reveals a clear roadmap for policymakers, educators, and practitioners. Behavioral understanding now needs translations into real-world initiative. Bridging policy, intent, and field executions. For policymakers, it means making sustainability rewarding, provide tax incentive, streamline certifications like Green Building Index GBI Malaysia, and ensure consistency between local and national framework. For educators, it means integrating behavioral science and sustainability into architectural and engineering curriculum. We must prepare students to think not just like builders, but like change makers. So for industry leaders, it means leading by examples, create in-house sustainability champion, share success stories, start small, like retrofit an office, choose a green materials, and demonstrate demonstrate all of this work. So the beauty of innovation is that it multiplies when people see results. So I believe the future of sustainable design in our regions lies in collaboration across borders. Malaysia, Indonesia, Brunei, and other ASEAN nations share similar climates, resources, and challenges. Imagine what we could achieve in our universities, industries, and government jointly develop ASEAN green standards, rooted in tropical realities, cultural diversities, and shared aspirations. We already have the research, we already have the expertise and the motivations. What we need now is collective action, a shared regional ecosystem that celebrates local materials, support innovations, and values environmental responsibility as a mark of progress. Together, ASEAN can champion a sustainability model that reflects our identity, adaptable, inclusive, and grounded in our natural environment. So let me end with reflections. Every building we design tells a story, not just of architecture, but of intentions. It reveals that we value as a society. When we build sustainably, we tell future generations we cared enough to plan ahead. In coaching, I've seen quite transformations taking root. Young architect experimenting with local materials, contractor asking for sustainable options, and communities demanding finding better living environments. Yeah. So these are the signs of change. So as we leave this conference, let us take one shared message. Yeah. The most important materials in sustainable design is not bamboo, concrete, or steel. Yeah. The most important materials in sustainable design is not bamboo, concrete, or steel. It's human intention. Yeah? We can align our knowledge, our behavior, and our sense of responsibilities, then innovations will naturally follow. Yeah? Together, let's design buildings that breathe with the environment, cities that care for their people, and communities that stand as legacies of our collective wisdom. Yeah. Thank you, terima kasih, and may this conference continue to inspire new stories of innovations, sustainability, and hope. Thank you very much.
Thank you, Dr. Wilson, for that enlightening presentation. We will now open the question and answer session with the question from the audience here and from our online participants. Okay, please, Budiska. Good morning, Dr. Wilson.
Sorry, the voice is not clear. Can you speak more loud?
My name is Fiska Hidayat, a lecturer in the Department of Engineering Accounting and Pontianak, focusing on sustainable and green architecture, as well as smart building design. Thank you for your insightful presentation. I'm particularly interested in how behavioral factors influence sustainable practices in construction. I have two questions, if I may.
The first one.
First, in your study, which element of the theory of human behavior do you find most challenging to strengthen attitude, social norms, or perceived behavioral control? Second, if we project into the next decade, how do you envision the evolution of sustainable and smart construction practices in Southeast Asian cities like Kuching or Pontianak? Because in Indonesia, I noticed that the implementation of sustainable and smart construction is still concentrated mainly in Jakarta. Thank you.
Sorry, can you please repeat the second question, please?
The second question,
Yeah,
if we
second
project into the next decade, how do
Pardon?
you envision the evaluation of sustainable and smart construction practices in Southeast Asian cities like Kuching or Pontianak?
I couldn't hear you. The second questions. Pardon?
How do you envision the evolution?
Pardon?
Maybe I will write in the chat box.
Sure. Okay. So I will answer the first questions first. All right. So the first question is, I think, important questions that one that reveals the heart of our findings. So in coaching, the most challenging element isn't attitude. Most professionals already believe in the importance of sustainability. Nor is it entirely subjective norms. The industry, networks, and policy are slowly reinforcing the expectations to go green. The real challenge lies in perceived behavioral control. The sense that, can I actually do this? Many practitioners face real constraints, like limited access to green material, higher upfront costs, lack of technical expertise, and inconsistent client demand. Even when intention is strong, this barrier makes sustainable actions feel out of reach. So while hearts and minds align with green ideals, hands are often tied by structure, strengthening perceived control through incentive, training, clear implementation support, it's where coaching green transitions must now focus on. So that's the first, my answer for the first questions. So for the second questions, let me check in the inbox. Check.
Okay, the
Question.
second question here is, if we project into the next decade, how do you envision the evolution of sustainable and smart construction practices in Southeast Asian cities like Kuching or Pontianak?
Okay. Thank you for the second questions. Yeah. It's wonderful forward-looking questions, because the next decades will define how our region builds its future. I believe Southeast Asian cities like Kuching and Pontianak are entering a phase where sustainability and smart technology will converge, not as separate agendas, but as one ecosystem. Yeah, buildings will no longer be static structures. They will become responsive systems using sensors, data, and green materials to optimize the energy use, water management, and comfort in real time. So locally, I see traditional wisdom merging with innovations. Passive cooling, local materials, and community-centered design pair with BIM, building information modeling, AI-driven construction planning, and green certification system like GBI, Green Building Index, and Green RE, Green Real Estate in Malaysia. But the real transformations won't just be technological. It will be behavioral. As younger professionals rise, digital native, sustainability minded, the culture of the construction industry will shift from compliance to convictions. So a decade from now, I envision cities like Kuching and Pontianak not merely building smarter, but building with purpose. So where sustainability is no longer an option, but a shared identity, rooted, a shared identity of progress, rooted in our tropical, cultural, and human context. Okay, thank you. I hope that answered the questions.
Okay, now we have one question online, and no, two questions online here, Doctor. First from Mohit, to what extent can this concept be compatible or in conflict with urban farming, especially in the context of advancing green urban architecture, given that urban farming inherently relies on active communities, community engagement, and the cultivate Okay, I will replay. Sorry. I will read the question again. To what
Okay.
extent can this concept be compatible or in conflict with urban farming, especially in the context of advancing green urban architecture, given that urban farming inherently relies on active community
Engagement.
engagement and the cultivation of pro-social behavior.
Okay.
Okay.
Thank you. Okay, thank you,
Okay.
MC. So that's an insightful question, because it touches on the delicate balance between technology and human connections. So in essence, sustainable and smart construction is highly compatible with urban farming. Both aim to choose the loop between people, place, and environment. So when designed thoughtfully, smart buildings can integrate green roof, vertical farms, and community garden courtyard, supported by sensor that can monitor the soil, can monitor the light and water efficiency. So the potential conflict arises only when technology becomes detached from community, when the focus shifted from participation to automation. So urban farming thrive on shared effort, learning and stewardship, qualities that humanize this. So the keys lies in designing smart system that enables, but not replacing human engagement. So in doing so, green urban architecture and urban farming can evolve together, creating cities that are not only intelligent, but also compassionate, productive, and also socially cohesive. Okay. Okay, thank you.
Okay. What do you think, Pak Mahmud? Is it clear enough? Okay, now let's move to our next question here from Burisa Saputri. All right, please ask the question. Where's the committee? Give the microphone to Burisa.
Okay. The next question is
Thank you for the
project in my
opportunity. My name is Lisa Shafutri,
Okay.
from the Department of Architectural Engineering. So I have two questions based on what I have experienced back in 2018. So I ever involved in a participatory project in the city back in 2018. We did mapping a certain area that's settled by marginal community. Honestly, that was quite hard to do, especially when we have to report back to the progress to the policymakers, because they don't think that kind of framework is practical. So from what I have been experiencing, how can policymakers translate the findings, this research, into actionable strategies to accelerate green building adoptions, especially in Southeast Asians, Indonesian to be specific. And then the second is, what are the most significant barriers to policy clarity that can potentially hinder the adoption of sustainable construction plans?
All right, thank you. So that experience you shared captures the common tensions, the gap between research insight and policy executions. Yes. So first, to translate research into action, policymakers must bridge evidence with implementation's capacity. So findings like things like ours highlight behavioral drivers, attitudes, norms, and perceived control, which can inform targeted interventions. For example, policy should not only mandate green practices, but also should empower practitioners through incentive, such technical training, and streamline approval processes. It's about turning data into dialogue, ensuring that regulations speak the language of those who build. As policy clarity, the biggest barrier is often fragmentation. Too many guidelines, inconsistent standard, also policy cycles. Yeah? This can create uncertainty, risk. Yeah? This can create uncertainty, especially for developers and contractors in balancing costs and compliance. So, to overcome that, we need coherence and continuity, okay? Unified green building roadmap that aligns locals' authority procedures, financial instruments, and national sustainability agendas. Only then can policy move from being a checklist, okay, to becoming a catalyst for real transformations on the ground. I hope that satisfied your question just now.
Okay, Buristan. All right. Thank you very much, Dr. Wilson, for your insightful answers and for addressing all the questions so clearly. We truly appreciate for your valuable time and contribution to today's session. Let's give big round of applause once again to Dr. Wilson for such an inspiring presentation and discussion.
Thank you so much for the warm welcome. Thank you.
Okay, now we invite Dr. Wilson and everyone in the hall to join our virtual photo session together. Okay. Okay, kindly turn on your camera, everyone, and smile for our documentation. All right, in 1, 2, 3. Yeah. Okay, one more time. 1, 2, 3, go. Thank you very much, Dr. Wilson.
Thank you so much.
All right, ladies and gentlemen, our next keynote speakers. Okay, our third keynote speaker join us online from Brunei Darussalam. Please welcome Dr. Rozia Binti Haji Adnan, Assistant Professor and Program Leaders for Architecture at University Technology Brunei. She holds a PhD from the University of Nottingham, United Kingdom, and is a RIBA Chartered Architect with extensive experience in sustainable housing and urban design. Today, she will present Kampung Air, a sustainable settlement in the urban context. Good morning, Dr. Elzia.
Good morning, Madam Moderator. Thank you very much for that introduction. Okay, so I hope everybody can hear me. Yes,
Yeah,
okay,
it's
just
very nice.
thank you
It's
very
a
much.
pleasure to see you with us here at ICArUS 2025, Doctor.
Yes, thank you very much. In fact, I have to tell you, I have to share with you that this is actually my first keynote presentation.
Oh,
So thank you so
all right,
much
we have
for
every.
giving me this opportunity. Okay,
All right.
so this morning I'm really looking forward to tell you a story actually. So this about the Kampung Air, which is our pride heritage in Brunei Darussalam. So the way we'll present this talk will be more sort of like storytelling, I think. Okay, let me share my
All
slides
right.
first.
Okay, before we begin, Doctor, just a gentle reminder.
Yes,
You have 30 minutes for your presentation, and
yes.
then followed by our question and answer session. Once again, we delight you here with us. Now the screen is yours.
Thank you very much. Okay, just want to check. Can you see the screen?
Yes, doctor.
Yes, so it should be, can I just, I'm gonna put it onto slide mode, if that works. Does that work? Okay? Okay. Okay, so
Okay.
Assalamualaikum and good morning, Pontianak. It's so good to see you today. I will talk about our Kampung Air and the living heritage on water. Okay, but before that, maybe I will. Can you hear me? Yeah,
Doctor,
okay. Yes.
yes,
Oh,
Dr. Rozia, you may continue.
thank you very much. So, first of all, please allow me to introduce myself. I am Dr. Razia. I'm an architect by profession, and I've only been in the university for 4 years. I'm quite new to academia. But before that, I was an architect for the Housing Development Department. So today I will show you some of the projects that we did at the Housing Development Department that's related to the Kampung Air project as well. Okay. So first, I will show lots of pictures in this lecture. It will be quite exciting. The first picture you see here is in fact our Sir Omar Ali Saifuddin Mosque in the Bandar Seri Begawan town center. It is one of our most famous and first mosques in Brunei. And it was during our late Begawan's time, that is our current Sultan's father's rule. So the mosque is named after him. And if you see at the sort of at the lower part of the picture is part of the Kampung Air that no longer exists. It is gone now. So I will tell you the story of how that happened. Okay. So first we'll introduce a bit about Kampung Air, and then I'll talk about the housing schemes, national housing schemes, and then back to Bandar Seri Begawan, where the Kampung Air is located, and then the conclusion to the talk. Okay. So first, we are not so far away from you in Pontianak, where we share the same the same island, Borneo. Okay, so Brunei is indeed a sultanate, so we have a sultan that rules the country. So our population as of last year was just under 500,000, 455,500. This is the map of our country. So we are divided into 4 districts. Brunei Muara, the pink one, and the green one is Tutum, and yellow is Blyth, and then the one on the far right is Temburong. Okay, so the smallest part of our country is in fact the densely populated one. So you can see there's about 390,000 of us living in the Brunei Muara district, and then a lot less in the other districts. Just a couple of facts that you need to know before we continue. 80% of Brunei is reserved for rainforest conservation. So what that means, the lower part of the country is all conservation, and then the urban developments are on the coastal line. Okay, so 20% of the lands are gazetted for urban development only. Okay, which is fine at the moment. It's still a lot of land for us. And then Temburong is the orange one is the rainforest district. So there's not much urban development there. So you can see the population is quite the lowest. Okay. And then, okay, these are some projections. So it is predicted that our population in 2040 will, in fact, sort of reach 1 million, 500,000, which is great. Okay. And then still Brunei Muara district is going to be the largest population of across the country. Okay, so now I'm going to talk about the Kampung Air. So Kampung Air is, sorry, let's go back again, just so you don't get lost. Where they have, they say the Bandar Seri Begawan, exactly where that dot is, and then where I've shaded yellow, that is where the Kampung Air is located. Okay, it's sort of at where the river meets the sea, the Brunei Bay, it comes in a little bit, and there's sort of like a lip in there. That's where the Brunei Kampung Air is. Okay, so here, it's got a sort of very odd shape. It kind of meanders a little bit and then around like that. Okay, so often Kampung Air is termed as the Venice of the East. Because it is actually a village on water, a living village on water, okay, with certain networks that go around it. Okay. So I'm going to show you next couple of old pictures. These are pictures of somewhere around the 1950s. Okay, it's black and white photos still, but you can see sort of some small houses sort of sporadically across the river like that, and they're actually located on either side. Okay, on the other side, and then on the urban side of the town center. And at the time, there weren't that many houses yet, just like under 100 even, just very small houses, like they're all scattered. It wasn't so full then, and then you'll see. And these are the type of architecture that was in Kampung Air then. They're wooden houses, and they're all self-built. There was no modern technology in it, all timber construction with timber panel, timber walls, all made and fabricated by the people who lived there. Okay, so you can see even if by 1950s it still looked quite vernacular. Okay, so during that time, the infrastructure is still quite young. There was no electricity there, no water supply. And how did they get it? They had to source elsewhere. Okay. But then when we became modernized, the late Begawan had the concept and the idea to bring Kampung Air into the future. So thinking about infrastructure, education, more public amenities that can service the Kampung Air. Okay. So the mosque was built, the one I showed earlier, the mosque was built, and there's a pathway that goes around the mosque. And this pathway, you can see from this picture, this is quite an important picture because there aren't that many pictures anymore of this. This entire area here is no longer, it doesn't exist anymore, but you can see the little bridges that connect to the circular path around the mosque. And that conceptually represents how much the Islam was supposed to be available to all the Kampung Air, and that was the main religion that would be leading the community. So it was important that everybody, all those had access to this mosque. So this is quite interesting, I think. Of course, the bridges are just a path. There's no safety issue then. So, back in the 50s, there's no concern about safety. Those who lived in Kampung Air they knew themselves. They can even run on this footpath. If I go on this footpath, I think I would be worried I have my toes stuck in the gaps or something like that. But it was very unique, those who live in Kampung, they were of a certain type of character as well. So this is a more recent picture. You can tell because it's more color and more precision. So by this time, as the Kampong Air grew in the 80s and coming into the 90s, more infrastructure came into the Kampong Air. You see those public buildings in the far back, that's a mosque. And then the next to it is a fire station. Yes, so that indicates that frequent fires occur in the Kampong Air, and they needed to have this kind of service to help with the combating the fire. And then next to the fire station is actually a school. So these kind of structures were long. These are sort of long structures, long buildings that are sitting. They are sitting on columns that are in the water as well. So infrastructure became part of the kampong. And it's really strange because you can see that the fabric is no longer kampong, it's becoming more urban. But we still retain the name kampong. Yeah. So now this is an aerial view. So in Kampong Ayer, they are also subdivided into smaller kampongs, and each kampong will have their sub-infrastructure as well, their own mosque, their own schools, clinics even, everything like that. And then you can see in this picture the network of footpaths that connect the entire Kampong Ayer. Okay. There isn't actually a footpath that connects this side, the left side of the Kampong Ayer to the city. So by way of getting there is by boat. So this is quite unique. Okay. So if you ever visit, if we ever visit to Kampong Ayer, we have to take the boat. Another aerial view, and you can see the boats all there, moving in there. Okay, so in this picture, again, the far left, you'll see schools. The schools are, they follow a lot of the design from on land, okay, with classrooms and then this kind of courtyard design. So even though the structures are big, the we see the Kampung Air becoming more and more urbanized, but still having that quality of kampung, particularly the houses. Okay, this was, I think, what gives the Kampung Air its uniqueness, that it is an area of houses that still are quite dated, but are in the moving with the times. Okay. So Kampong Air is made up of sub-kampongs as well. As it grew, they had to do that, and each sub-kampong has their ketua kampong. Exactly, ketua kampong is like village head. That's exactly the same sort of model that is practiced on land. So they start to see this kind of relationship forming, how we are modeling our infrastructures from land to water. Okay. Not really sure if it works, but somehow so far so good. Okay. As I forgot to also mention that the first infrastructure, most important infrastructure we put in here was the electricity and water. That was the first thing that we implemented in this Kampung Air. Okay, so the Kampung Air, they divided into small villages called mukims, and then all the mukims have their names: Burung Pingai Air, Peramu, Sabah, and Sungai Kebun, and so forth. And under the mukims, there are even smaller villages. You can see here on the table here. Okay, and then these are the populations. So all in all, there's about 10,000 over people living in Kampung Ayer. That's just less than 5% of the country. But nonetheless, still very important, because the Kampung Ayer is believed to have been existing for over 800 years. Okay, so it is a national heritage. So these some pictures of the type of houses that are there. So The one on the left shows this is mostly a one-story house. Okay, and you can see already the infrastructure in the house is no longer looking like kampong. They have TV satellites, air conditioning. Yes, this is, I think, what adds to the character of Kampung Air, that they're able to, that they still maintain their self-character. They call it character, distinctive character, but still have some modern amenities incorporated in there. Okay. Now later on, there was a concern about the structures that hold the houses up, the columns, if you like. So this again was one of the earliest concerns of the durability and the strength of what holds. Because in the past, there were many houses that collapsed because over time the timbers are not treated, but they eroded and they were weakened over time because of the water, and a lot of houses collapsed. So this is the extent of engineering that we apply this reinforced concrete structures that hold up the houses. And this seems to have been very successful. It's much more durable in that sense. Sometimes, just a little story here while we're on this slide, sometimes some of the houses that are really, really old, but they have already got the columns in place, they will rebuild on top of the columns. So get rid of the old one and they will rebuild a new one. So in a way, it's a kind of renewing, adaptive reuse, if you like. And in some way, you can perceive it as a kind of sustainability because they are reusing the actual site as well to make new and still live at the same area. Okay, and then the image on the left is showing the character. Now, this is quite endearing. People in Kampung Air are very proud of their houses, even if it sometimes looks a bit rickety, but they love it and they always put their personal character to it. And this is what we love. Okay, and there's many more like that. Accessibility to Kampung Air from the town center. Again, about the paths and walkways. And sometimes there's some of them using bicycles if they're carrying things. So how it works is they would go to the city or town center and buy their provisions and whatever they need, and then bring it back to their homes. So that's how it works. There is a kind of a relationship between the Kampung Air and the city center. Okay. And it's important this way. It seems to work in terms of their livelihood and how they live. Okay. So the two pictures on the right, I love these ones because this shows the infrastructure, the electricity and the water supply that goes to all the houses. So the blue piping that you see on top of the footpaths, they put there. Sometimes in some bridges, the pipes are placed underneath. So it really depends on the type of construction and where they put it. And then you can see all these electrical cables all networking through the houses. Okay. All right, so this is a picture of how Kampung Air people access to the town center by boats. So it gets really, really busy in the morning and especially in the evening. So a lot of Kampung Air, people live in Kampung Air actually work on land. They have jobs in the city. So they all come in here every morning like this, coming in, and in the evenings also going home with these boats like this. Now, here's a tip I will share with you. They know who lives in Kampung Air and who doesn't, including not just for foreigners, but even for locals. So when they see me, they know I don't live there and they will charge me maybe $2. If you live there, if you're a person who live in Kampung Air, it's only 50 cents. So there is a kind of distinction with if you live there and if you don't live there, no matter if you're local. So they have a very distinct identity as well for people living in Kampung Air. Some of the activities on water are things like regatta. Regatta is we have regatta competitions. Normally, when there's a auspicious event in Brunei, this is quite famous. Well, so but what that means is that Kampung Air is also celebrated when there are events like this. So the more they have activities, uh, national activities to do on water, this is very good for Kampung Air. Okay. So one of the problems I think that occurs, as I said mentioned earlier, was about fire. Fire often occurs in the Kampung Air. So you can see here some guys from the pemeliharaan bomba. Okay, sukarelawan bomba putting out fires. Okay, so there was a concern about maintenance and safety of Kampung Air, those living in Kampung Air. So sort of in the 50s, there was a discussion about perhaps moving some of the people from Kampung Air onto land. So that started the first national housing scheme known as the Perpindahan Kampung Air scheme. Okay, moving people from Kampung Air onto land. So this one in 1988, this was, hang on, before that, this is the Kampung Air that no longer exists because in this there was a massive fire and a lot of houses were destroyed. Okay, so that was very sad for us when this happened. You know, Brunei is such a peaceful place. It was a lot of people were upset about this. So National Housing Scheme, okay, started in 1950s, and it was a pilot project at first. We're not really sure. We do, it is quite sensitive, you know, moving people from one place, especially when they have been living there for some time and there has been deep-rooted history. You find that it's not a simple thing to do. So this was a test project at first, the relocation of the residents from Kampung Bandar Lama to Kampung Bunut, about 28 houses, very small number first. Okay, and then later on, 2 years later, they tried to move a few more others as well. So the black and white picture you see down, and that was the typical design of the houses. Okay, one of the strategies to move people over was maybe if we emulated houses that look like Kampung Air on land, that might attract the people or ease their transition over, so it's not too emotional. It worked to some extent, but mostly a lot of people were still very attached to Kampung Air. Okay. And it is something that I think as Brunei, we took it seriously. We understood this connection with the people. So we had to rethink again, like how we are going to do this, because for thinking about it in the future, it might be difficult to sustain the Kampung Air. But in any case, so that bit that I circle here in yellow, that was where the Sumbiling Lama Kampung Sumbiling Lama was, and that whole houses got wiped out. And this part was converted into a eco park, like a park. So that site was abandoned for a very long time from the 80s, almost 2 decades left abandoned. Didn't quite know what to do about it. But in any case, in the last 10 years, this was what we did in terms of urban planning. Okay. So in that circle, you see are two very important buildings. Okay, it's the Omar Ali Saifuddin Mosque, and you can see the circular path that I mentioned earlier. Okay, so the purpose of that path was actually to access for the Kampung Air people to onto the urban part of the city. But now that this has happened like this, it doesn't quite function like that anymore. Okay, it's more sort of like a aesthetic landscape around the mosque. And then the sort of grayish building you see down below there, that's the Yayasan. That the design of the Yayasan was actually to create an axis of the mosque to the Kampung Air. So you can still have that connection from Kampung Air to the mosque as what was aspired to earlier in the 1950s when the mosque was first built. So this area, again, has quite history and trying to make the content of this all connect. Okay, this is really important in terms of the historical identity. Okay, so you see the two pictures on the top on the right side. That's what it was before with the houses. Nice also. But then the new park is something that is new to Brunei. It's the mark of us coming into the future. Okay. So I just want to touch a little bit about the story of the National Housing Scheme, the Housing Development Department. So now Housing Development Department also has very roles. It's responsible for the relocation scheme, but then later on went on to come bigger in terms of the Rancangan Perumahan Negara, the National Housing Scheme. Okay, and this is where His Majesty is very much involved in this part. Okay, so later on, the Jabatan Perpindahan Kampung Air, the relocation scheme, was renamed Housing Development Department in 1984. And this idea went on to provide national housing, and it was no longer about relocation. Because of the success of the relocation, a lot of ideas popped out that it could become a bigger housing plan, and which it did in the last 70 years, it did. And this map here shows the housing areas right across the country, and then many in the Brunei Muara district here, and then a few in Tutong and some in Blaid, and then one in Tumburong because it has the smallest population. Okay, so just another fun fact, okay? The Department of Housing Development is one of the departments under the Ministry of Development, entrusted by the government of His Majesty, the Sultan and Yang di-Pertuan of Brunei Darussalam to plan, design, implement, and manage the maintenance of national housing schemes for the country of Brunei Darussalam. Okay, so our role, sorry, sometimes I say our because I used to be in housing. So the role of housing became a lot bigger, not just providing houses, but also taking care of the quality and the maintenance of these housing areas. Okay. So one of the earliest housing schemes looks like this. Okay, you will see that similarity of houses from Kampung Air, houses on stilts, large, and each house consists of 3 bedrooms, a living room, and a kitchen, and a dining area. Okay, so the basic features of a typical house, if you like. Okay, and then what's nice about this, so in Kampung Air, the bottom part of the house is where they would keep their boats. But in this case, because this is a scheme on land, you'd keep your car and other things. And sometimes underneath the house, they would organize activities, tandoori, things like that. And the earliest housings had big land around it. You can see here, quite big. The houses were very spread out and they were big as well. One of our largest house models was in the earlier housing schemes. Okay. Now, for the earlier housing schemes, that structure led to house extensions. So, kampung RP rumah perumahan negara kampung Lambak Kanan. This is one of the earliest. It started in the 80s. So you can see the amount of land, the land plot area was quite luxurious. So if you can just look at the middle, one of these houses, the structure in the middle, that is the original house that the government provides. And then the extensions all around it, that is done by the house owners. So we see this happening a lot. We don't have any restriction about it, just a basic rule about not to go beyond the building line, which is 3 meters within away from the plot boundary. Even that you can see it's quite big. So our little modest house became something quite like a mansion like this. Now, during this time in the 80s, Brunei is still having extended families. You know, families are big. They had like 6 to 8 children. So these sort of extensions were inevitable. It happened because the families grow. So it had to happen. And this housing scheme, very popular. It worked out really well. People were happy because they were able, because of that flexibility, they were able to expand their houses according to their affordability as well. You know, it didn't happen overnight. It happened in time and over generation as well. Okay, so this is very good. But then coming into the end of the 90s and to the turn of the century, we start to see more and more demand for this kind of housing. But of course, if you increase the number, such is the budget as well. So there was this sort of thing where we had to juggle between budget and the number of houses and trying to meet targets of how much houses we had to produce each time. And then we started to look at smaller spaces, and then taking precedence from the people who the previous housing areas where they bricked up the bottom part of the house. We started to do houses like this as well, double-story houses. This is great because it allowed us to reduce the plot size and the area of the house and build upwards. Okay, so then the housing schemes then were, you will see something like this, sort of double story. And then to think about the efficiency of the plots, we started to do cluster housing schemes where you have 4 houses together and even terrace houses like that. Okay, so in terms of me providing the houses, that worked well. But looking at a housing scheme like this, sometimes it's questionable about the community aspect. Is this really what are the social outcomes of a housing scheme like this? Even though we are able to provide the houses, but you know, you have to think about the design as well, especially with housing. So some of our sort of midway other housing schemes were still a lot of land and still thinking about community as well. We had this kind of in the Kampung Mengkabau where you have a cul-de-sac type of design where you have a set of 8 houses in a cul-de-sac and things like that. This kind of design was much more lucrative for community building. Okay. Yeah. So something that we had to think about really and way out, meeting the producing the number of houses, or we looking at community is all both. Okay. So by this time, you know, in the late 1990s and early 2000, we started to think about prototyping and coming up with the standard layout but each time, each housing area will have their identity in terms of color of roof, styles. We started to define each area slightly different from the other, adding these sort of fancy little features here. Okay, so if we saw a house like this, we know which kampong housing it came from, and so forth. Okay. So going back to Kampung Lambakanan again, sort of in the early 2000s, we seriously started to think about high rise. High rise was something that we weren't too sure of at the time, because we still like our house and a bit of compound around it. This high rise is something new, and we had to ease this idea into the communities gently, okay, not so abruptly. So the first scheme for the flats, if you see it on the image at the bottom with the blue line there, okay, that's our first high rise. Okay, it's about 6 floors of houses. I'm sorry, 6 floors, unit floors, and that's one example of it. And although it looks very lavish, but the idea was we wanted to have that sense of community for the people living in this, because it is something new, and we didn't want people to feel a bit estranged in that. Alhamdulillah, luckily, those who chose to, who were quite keen for the flats, they really like it. So you're looking at most of the younger generation love this kind of design. So that's very good for us. And where this is located is very near to the older scheme. So you see a kind of the idea of having old and new. This was emerging as a concept for us, and then that picture I put in there, it's traditional group of, or slightly older group. In the evenings, they like to perform the traditional instruments. We feel this is very good for a housing area, that you can see the culture also there. And then as the new come in, hopefully they'll find a way to link and live in harmony in that respect. Okay. So, we haven't forgotten about the kampung air. So we go back to the kampung. Now, could this idea of a mass housing model work in kampung air? Seeing as how it is such a contrasting approach. Okay. So there are 3 schemes. So in 1986, that was the first one in Kampung Sungai Bunga, about 56 houses. Yeah. This one was mixed reviews about this one. Okay. And I think because it was also located very far away from amenities, it was quite difficult. So the second scheme was Kampung Bolkia A and Bolkia B, a little bit more houses here. That worked a little bit because it's much closer to the town center. But then not really, okay? Didn't quite have that same impact like if the houses were closer to the town center. So we sort of realized then that the town center plays an important role for these kampongs. So the third scheme, called the Kampung Diraja Muda, was in 2011. So you see, and these housing scheme are the double-story housing scheme. Okay, so it worked very well in this respect here. Okay, so Kampung Air has 3 housing areas to date. There hasn't been any new one yet. Okay, so this was quite interesting actually for us now. We're looking at how housing schemes work, right? They need, there's not just the house alone providing the number of houses. It really needed to have all those infrastructures and amenities like shops, schools, mosques, and all those sort of things, right? So where we place the housing areas is also important. It must be considered quite carefully in the beginning before any houses are put there. Okay. So that's one of the things we learned, I think, when we over the decades about housing areas, housing schemes. In any case, we also looked at housing designs. Here are some of the earlier proposals for Kampung Air. Okay, from a single story and then a double story. Okay, here, yeah, that's it. So you can see they have 3 bedrooms. This might be, we might share the same concept as well. 3 bedrooms, one is for mother and father, one for female children, and one for male children, like that. Okay, and here's a prototype for the double story. Okay, so when you have the double story, there's different typologies for the houses and how they use the spaces for. So the one at the bottom is more for bigger public engagements, and then at the top you have more private for family get-togethers. And then here are other types of housing, and then you can see the kind of it's becoming. These are just ideas. We haven't built this one yet. An idea of like terrace housing on water, and then a triple story on water. These are just ideas that we are mulling about. Okay. And then slightly more complex kind of structures as well. Okay. So I just want to now talk a little bit more about the Kampung di Raja Muda, which is the third housing area. Now, this one is the housing area that is actually set inside the original Kampung Air. Okay, so I really appreciate this picture because it is showing the scale and the harmony of 2 eras of houses on Kampung Air, and then you see the electricity cable there and the water supply pipes there. But it's only like over the years you can see how the people living in these structures really make it their own, and that's actually the interesting part. Okay, there. So the way they are already starting to personalize the houses, they add roofs, they add things, they start to tell us whether, if these houses work or don't work, or how will it work. Okay. So this character or habit of extending the houses and manipulating, changing, renovating it isn't new, in fact. If you go back, so we look back at the houses that were already there, how they actually grew. So this was part of my PhD, trying to envision or think back about how the houses were extended. So you see here these little sketches on the side. The original house, and then stage 1, stage 2, stage 3, and you can see it all being extended all the way to the back, adding rooms, adding kitchen, toilet, things like that. So you can see the house is almost doubling in floor area by the end of it. So that got us thinking about how the Kampung Air actually grew. It could be all this time we thought the number of houses were increased. It could be as well, but also over time, the houses also grew in this manner. Okay. So even with the new housing schemes that we put in there, okay, you cannot help the character. This is their character. They will manipulate and they will add on as see fit as their country, as their families grow. See? And so in the beginning, when this happened, we sort of perceived it as, oh, this cannot be, this is melanggar syarat, this isn't
Excuse me,
correct.
Dr.
But
Razia.
then at the same time,
Hello,
they
Dr. Razia.
constructed this out of their own pocket, out of their own fund. They didn't ask anybody else to fund it. This just came from them. And that gave us an indication of a strong sense of self-responsibility for the people. They can manage themselves in a way.
Dr. Razia,
Yes. Am I running out of time? Okay, I'll finish off soon.
There are about 2 minutes to wrap your talk.
Thank you. That's all I need. Thank you. Okay, so these are sort of some things we were learning about, especially in my PhD when we started to look. And as when I was doing this research, even though I had a very technical methodology, but when I went there for about a month researching here, we got to know the people. And this, I think, was a very unique and important by outcome of it, getting to know the people. So here it is now, Kampung Air, okay? We are no longer forcing people out, or we're no longer thinking about diminishing the Kampung Air. We're now thinking about celebrating it even more and helping it to grow. So these are quite recent infrastructures. In 2017, there was the Raja Istri Pengiraan Saleha Haja Saleha Bridge, okay, right next to the Kampung Air. And this is a way of now we are moving Kampung Air actually into the future rather than on land. Okay, so we are growing, the idea of that we are growing together. And this building, this is the Kampung Air Cultural and Tourism Gallery. They have that as well in Kampung Air for tourists. Now, Kampung Air, the way to keep it alive is actually to visit it, to always be in our minds. So we started to incorporate visits, part of the design studio in our students' curriculum in this way. So this was getting them to see Kampung Air, travel, even the traveling to Kampung Air, believe it. Some of these students tell me this is the first time they've been to Kampung Air and on a boat. I mean, that was amazing. And this is one of the houses in Volkia A. They converted their house into a tourist attraction, so tourists can visit and learn how to make kelupis, which is I think you have it. I'm not sure if you have it in Indonesia as well. It's rice, sticky rice wrapped in daun, wrapped in a leaf. Okay, so this is very good. It's really making the students think about Kampung Air and the urban in that sense. So now this new concept emerging is about growing together and always helping each other. There is a sort of symbiosis going on between the urban area and the historical part. So this is a recent picture now. So let me just explain. So from that circle that you see, we've also developed the riverside. There's a river walk that extends all the way to the right side of this picture. Okay, this walk. So in the evenings, when it's not so hot, some Bruneians come down here and do their jogging. Lots of people come to jog up and down here. But while they're jogging, they are always seeing Kampung Air. So this is probably the first step in keeping this Kampung Air alive, that we are always watching it, seeing it, that it's always in our view, and then eventually it's always going to be in our hearts for the new generation. Okay. So some of the learning outcomes, we learned about old and the new living peacefully in harmony. This is good. Encourage organic urban growth with flexibility in urban planning and design. Very, very important for those who live there. They need to be able to grow and integrate their own character into the area. Community is key to sustainability and resilience. Absolutely right. Even though we are planning, we are on the outside of it, but we have to also see the people and make sure that whatever we propose, it is suited for the community. They are able to live in it. this is not a simple process. Not at all. It's very difficult, but very learning and very fulfilling once we do it. So in conclusion, urban infrastructure has been integral in improving the quality of life in Kampung Air. That is true. In the last 70 years, it's definitely proven that. Kampung Air and the National Housing Scheme are closely related now in providing viable solutions to housing for Brunei Darussalam now and in the future. Okay, so even though we don't have like an emergency, it's not a state of emergency yet about housing. We're all very settled. We have roofs over our heads, but it's nice to have this time, it's a luxury to think about what type of future for housing we are going to make. Okay, and it will take time. So Kampung Air, well, I guess it will continue for generations to come, inshallah. Thank you very much.
Okay, thank you, Dr. Rozia, for the meaningful presentation.
Thank you.
All right, now we will move to the question and answer session, consisting of 3 questions from our on-site and online participants. Okay, please begin. Hello, Ms. Dr. Rozia.
Hello.
Thank you very much for enlightening presentation here.
Thank you.
I would like to first I want to introduce myself. My name is Dian Saria from Politeknik Negeri Pontianak. I have one questions for you related to your topic, especially in connection with local context here in Pontianak, because we have Kampung Air too in
Yes.
Pontianak. We call it Kampung Beting.
Yeah.
Okay. Many river settlements in Indonesia, including Kampung Beting, also face issues such as bad sanitation, flooding, and land pressure from urban expansions.
Yeah.
Based on your research, what lesson learned and strategies can local government adopt to transfer such areas into sustainable and inclusive communities? Like we have this here, case study here, Kampung Beting. Thank you very much.
Okay, thank you very much. I think before I answer this question, thank you very much. That's a really valid question. It's quite tricky, when you ask me things about my government. I think first of all, location, I think, plays a really important role. Location, and that's in a sense, what are the amenities that are nearby to your Kampung Air? I think that's the first thing that we need to look at first, okay? And then study how people live in that area. Often we find, we did a sanitation proposal a while back in one of the kampung, Sungai Bunga, I think the first one, using vacuum, the vacuum one. But it didn't work out too well. I'm not sure why. I think even a vacuum system like that requires maintenance. So when we looked at strategies, we also looked at the maintenance implication of all the strategies. Okay, and then thinking about whether it would work with the Kampung Air, because the Kampung Air doesn't quite have the same context as the developments on land. So there were things that we needed to consider when we think about what strategies we want to apply, right? And sometimes when we go through the process of thinking about it, we find that it's too much trouble. Sometimes some of the strategies cause far more problems than it does solutions. Yeah. So when we look at the Kampung Air, we have to understand as well the sort of level of how I say without sounding the level of the people that are living there. Okay. Some of them are elderlies. They came from a generation that are not too high tech, not so high tech. Yeah. So I think that's why when we thought about these strategies in the beginning, a lot of it was not favored because of that maintenance. We wanted to look at something where the people can do the maintenance. It was not too difficult like this. But then now, that was about maybe 20 years ago, we thought about this. But now that we are now in 2025, the generations are different. Okay, but the younger ones are a little bit tech savvy. So maybe we can consider the those techniques again back again and see how we can um, adopt those. Okay. So sometimes studying what the context is probably I would advise the first thing you would do, and then think about what are the strategies that might be suitable for that. And we're such we're so lucky to be in this era. There's so many technology out there. You know, there's definitely a technology for whatever context that you come up with. Yeah. So I hope that's, I'm sorry, I wish I could give you a much more definite answer, but it's difficult because the answer will only come once we have done the study, once we kind of define the context. So if I knew maybe a little bit more, we can discuss later. Yeah, after this, a little bit more about your context. I think that would be great.
Thank you for your answer.
Thanks, Diane. Okay.
All right, now next question, everyone.
I have a question.
Hi.
Okay, Dr. Bogi.
Hi, Muin.
Yeah.
Hi, Dr.
Hi,
Muin.
thank you
Yeah,
so
hi,
much for
hi.
the presentation. It's I see myself related to what you do. My PhD was about visual preferences, so there's a lot of community engagement. I used a technique or approach where I adapted a methodology from marketing, which they give participant options, three options that looks almost similar, where the attributes changes in the options, and then one answer says like none of these options I like, and this task repeat like 15 times, for example. It depends on how you design the instrument. Now, the cool thing about it, it reveals exactly what people likes, and so I found it is very important and powerful tool because it helps urban planners and also designers and like landscape architect as well to make a proper decision, very precise to word. Because when you ask people open-ended question, they can say a lot, but how to know precisely when they're exposed to trade-off between options, what kind of attributes in that design really affect their choice. And so was there any of these techniques you guys implemented in your study? And again, thank you for your presentation.
Yeah. Okay, thanks for your question. Well, there were a few, but maybe this thing about finding out what they like, in terms of the I think when they extended their houses, that was something that we were quite interested in. So when we did a survey about it, we gave them like multiple choice. We sort of saw what were the common things that were being extended right across the housing areas, and even in Kampung Air now, which part. And we did a survey that asked them, in order of which rooms they would extend or change, things like that. And and there was a sequence actually to it. The first thing that they would extend first is actually the living room area. And if they had a balcony, a pantaran or balcony, that would be boxed up first. So some of our designs, instead of a pantaran or a balcony or a veranda, we had a car porch. And the car porch is designed right next to the living room area. So over time, they would do that extension first, and that was common. So that helped us decide how much space in front of the house we need to provide, because we know that that is coming. Yeah, so that in terms of deciding the plot size, but even more so the plot area, the plot shape, and where is the entrance, like that just from that question alone, that helped us justify this. And then there was many others as well, because they later on they will extend the kitchen. So depending where the kitchen was placed and then how much room you provide, that went on to us coming up with proposals of how to extend housing. And that was really just about before I left. Before I left housing, it was so I'm not sure how how that panned out. But this was really important because it really helped us to determine the plot sizes, and that helped us maybe increase or even decrease the number of houses we would build in a housing area. Okay, so it wasn't, we're moving away from like, oh, we have to build 10,000, a couple of thousand houses. It's more like, okay, this is how it looks like, X number of houses, and this is going to be great because they're going to be able to live in it and form communities and that sort of thing. So like I say, we are so lucky that we don't have this like urgent emergency to produce lots of houses, but more now we can focus on quality and think carefully about it. And again, instead of saying one or the other, houses on land or housing on water, we now have both. So in future, if there was a demand for housing and we have limited land space, we have an option to go to the river. Okay, so hopefully by that time we would have worked out some sort of construction technology or I know schemes of models by that time. So yeah, so we're really keen now. What I need now is probably more collaboration. So I'm glad, Pontianak, you say you have very similar models, similar ideas, and when you're quite relating to it. So this is very good news for me. I hope that
Yeah.
answers your question.
Yeah, thank you. Yeah, yeah, we should be in contact because I'm interested in this.
Definitely. Yeah.
Right.
Okay, now one more question. No more? Oh yeah, please. Do this one.
Good morning, Dr. Rabia.
Good morning.
My name is Crystal Gayat. Thank you for your inspiring presentation.
Thank you.
I want to ask, how can these vernacular settlement principles be integrated or reintegrated within modern sustainable and smart city frameworks without losing their cultural identity? Thank you.
Okay. Thank you very much for your question. It is a question that I also ask myself. Okay, I'm curious too how this will be. Okay, let me show this picture. Look at this picture. So this picture that I show you now, okay. So you see the top right corner. That's our city, the town center. That's where there's shops, all the public amenities, banks, everything is there. But then, so the Kampong Ayer really needs to be here, nowhere else. And the city center needs to be there. They need to be able to reach each other. Okay? Because we found it from the two housing areas that we did earlier, Kampung Bokya and Sungai Bunga, they're so far away. Even that distance is too far. You know, they prefer to be here, so close, and just take a 2-minute boat ride, and then you can go on to civilization. You can go to the city. And that's what works. this is actually what works. Okay, so we as I'd say the planners or the designers, we have to work with them. We have to work with the people who live here, get some information from them, and design around them. This is what I think is good. Okay, so we are becoming less, we want to provide these sort of solutions or strategies and models that work. So this is what we need to find out. So we need to do more research. Okay, so yes, that's I think the first thing we need to look at like that. Yeah.
All right.
Okay.
What do you think about the answer from Dr. Rosia?
Okay.
Okay.
Thank you.
Yeah. All right. So, Dr. Rosia,
Yes.
thank you very much. Yeah, for the
You're most
great
welcome.
discussion and inspiring answer. Ladies and gentlemen, let's give another round of applause to Dr. Rosia.
Thank you.
All right, before we move on to the next agenda, we would like to invite Dr. Rosia and all participants here in the hall and online to join virtual photo session. Please turn on your camera. Okay, and give your best smile for the communication teams. All right, here we go. Okay, 1, 2, 3, go. One more time. 1, 2, 3, go. Okay, thank you very much, Dr. Rosia.
Thank you very much.
All
All
right,
right,
keynote
keynote
speakers
speakers
here
here
in
in
Pontianak
Pontianak,
is Azam.
Azam. So we
Continue
continue
after
after
Azam.
Azam.
Thank
Thank
you.
you.
tanpa
Ladies and gentlemen, our next keynote speaker is joining us virtually. Please welcome Dr. Yani Rahmawati, currently serving as an assistant professor in the Department of Architecture and Planning at Universitas Gadjah Mada, Indonesia. At Universitas Gadjah Mada, she also served as the chief editor for nationally accredited journals in the field of built environment and community engagement. Before joining Universitas Gadjah Mada, Dr. Yani was a senior lecturer in the Department of Civil and Environmental Engineering at University Technology Petronas, Malaysia, where she was appointed as project coordinator for a university consultancy project and as alumni coordinator. She was also invited as a visiting professor at the Faculty of Social Science and Humanities, Mahidol University, Thailand. Today, she will present her insightful topic, Green Meets Lean, a decarbonization strategy to do more with less. Let's warmly welcome Dr. Yani Ramawati, joining us online from Yogyakarta. Please give big applause.
Thank you, Madam Moderator, for the invitation as well as the brief introduction. Good afternoon, or perhaps still morning, yeah. Good morning, Professor, doctors, ladies and gentlemen. It's a pleasure for me to be here to share some of our work actually in the Department of Architecture and Planning, Universitas Gadjah Mada. Okay, let me share my screen. Kindly confirm, is it clear, my screen?
Yeah,
Can
clear
you see?
enough, Dr. Yani.
Okay, thank you for the confirmation.
Yeah.
Okay, so first and foremost, I would like to thank for the Committee of ICArUS 2024 for giving this opportunity. It is an honor for me for sharing this topic related with decarbonization strategy utilizing the lean construction. So basically, the concept of lean has been implemented in the manufacture and then it was adopted in the construction area. So that's why currently in Indonesia as well, we call it as a konstruksi ramping or lean construction. It is becoming trend in here because all of us in the AEC industry would like to have sort of a low carbon development in the construction sector. Okay, let me start the presentation with highlighting the differences of the development in the Western countries as well as Eastern countries. Perhaps Dr. Muin, Dr. Wilson, as well as Dr. Rozia later can share also about the differences of the construction practices in the Western and Eastern. So basically, this one is actually were summarized from the previous studies that we've been identified related with the sustainable construction. So in the Western country, we can see that they have regulatory frameworks focused on retrofit and net zero target. And then this one is actually a bit different with the development in in countries. So in here we can see that in Eastern countries there is an emerging population. That's why there is also a rapid new development domination in a construction or in a property development. So in here we can see in the Eastern countries, they actually focus on new building standards whereby they want to catch the opportunity to incorporate best practices from the inception, particularly in decarbonizing the operational and as well as the construction process. So the result from the carbon resulted from the construction process as well as the operational of the building or infrastructure itself, it can be reduced during the planning or design stage. And then we can see in here in the Eastern countries, in the Eastern context, we can see there is an emerging policy framework related with sustainable development, sustainable construction as well. And then there is also an emerging trend about the green bonds. So basically, our government would like to have effort or strategy to get finance from the investor to be able to develop new green infrastructure or green building and so on and so forth. So that's why in Indonesia, currently the green bonds is becoming trend. And then we can see in here on the Western context, like I previously mentioned, it's a bit different with the challenge that has been faced in the Eastern countries, whereby we are facing the rapid new development because of the emerging population. In the Western countries, we can see there is a strong enforcement mechanism and established financial incentive. One of the interesting incentive has been introduced by German. So Germany has KfW program, whereby this program giving incentive for the house owner if let's say they want to renovate their houses to be greener. So this one is interesting because in Indonesia we don't have this kind of program or this kind of incentive because we always have a mindset if let's say we should renovate our building or our we need to prepare lots of budget because it's not cheap when we are investing on the green building or green utilities and so on and so forth. That's why this is very interesting, the initiatives that has been given by the Germany government about the incentive for the house owner to renovate their house to be greener. And then this is the concept actually related with the green strategies, integrating the green strategies with the concept of lean management, like I previously introduced in the beginning. So basically, the concept of lean or lean management already been established in manufacture area. So and then it was adopted first, I think, by Koskela. I think that one before 2020 something. But this one is the other paper published by Koskela. So Koskela started to integrate or to involve the concept of lean in the construction. The main purpose is actually to minimize waste. So this effort is actually related with the strategy in achieving low carbon construction, whereby if, let's say, we can minimize the waste is not only the material, but also the processes and so on and so and so forth. So if, let's say, we can make a leaner process on the construction, we can also reduce the carbon produced during the process. And then these two factors is actually are actually related as well with the principle of circular economy, whereby we would like to have a closing loop, especially on the life cycle of the material to utilize in construction. So this is the basic concept actually, the green meets lean. We want to have a leaner construction process to be able to reduce the carbon as well as to achieve low carbon development or construction. And then this one is also the evolution of sustainable construction research. So we can see here in 1990s, lean construction principle is already been implemented. Actually, I think firstly by Koskela in his research, and then the concern about embodied carbon is also entering the LEED and BREEAM certification system. And then in 2010, the circular economy concept also being considered. In here, in Eastern countries, we can see Japan pioneers for the lean construction because actually there are lots of methodology in lean management coming from Japan. So we always heard about the Toyota's ways and so on and so forth. So basically, the concept of lean we can be found a lot in Japan. So in here we can also see the circular economy also already being considered in Eastern country as well, starting 2015. Let us move on. So these are actually the 7 ways that need to be eliminated utilizing the lean concept or lean management. So in here we can see in construction process, we can see sometimes we witness the overproduction, and then we also in a construction site having challenge related with the inventory system. And then we can see also the transportation. So when we transport the material, we also need to consider the embodied carbon that has been released during the transportation. And then there is also waste related with motion. And then there is also about weighting. So we would like to eliminate or reduce this kind of waste in a process, particularly in a construction process. The most important part is actually also the over processing and as well as defects, because all of this will tally or directly related with the budget, construction budget and its performance. Let us continue. So this one is actually one of the methodology of lean construction. So there is a lean planner system, and then there is also this one related with just-in-time inventory management. So when we are when we are constructing our building or infrastructure, sometimes the construction manager facing the issue in the inventory of the material, the system of the inventory of the materials. So there is always a conflict. How many or about the amount of the material to be delivered in the construction site. So the concept of just in time is actually purchasing or ordering the material, whereby when the material coming into the construction site, it will be directly installed. So there will be no waiting, no waste related with the waiting, and then the construction manager also doesn't have any conflict in creating or in building the construction in managing the construction site, because as a construction manager, he or she will need to provide a space to be able to store the materials. So this is one of the methodologies inside the lean construction. And then these are actually some of the implementation of the lean construction. Like I mentioned previously, there are lots of methodologies. The other methodology is last planner system, using the pool planning and constraint removal standardized across. This one is actually already implemented by contractors in European. And then there is also digital integration. So like I heard previously, Dr. Wilson shared about the BIM. So basically BIM helps a lot, particularly in minimizing waste during the construction process. And then there is also the integrated project delivery or IPD. This one is actually the contract model if we are utilizing the BIM or building information modeling based project. So basically in Indonesia, I believe IPD has not been started yet. So I'm not sure with Malaysia. Back then when I was in Malaysia, it has not been implemented yet. So not sure, maybe later Dr. Wilson also can share a bit about this. And then in Eastern, we can see in here some of the efforts as well, some of the strategies using the prefabrication. So basically, when we see the life cycle of material, and we also need to consider the concept of lean construction, we can eliminate or we can reduce some of the activities in a material processing using the prefabrication process. We can also utilize the modular system and so on and so forth. So basically, all of this effort, all of this strategy is actually wanting to have a greener construction process whereby we eliminated the waste as well as reducing the carbon produced during the process. Okay, so this one is actually interesting finding published by Agimian et al. In 2020. So this one, we can conclude in here that Eastern nation demonstrate higher adoption rates where governmental mandates exist, whilst Western implementation remains more variable and market-driven. So, like I mentioned previously, in Eastern countries, uh, the government actually establishing the framework, the regulatory to for the new development to be able to support the sustainable living, including the process of construction, operation, and so on and so forth. And in here we can see some of the countries, most of them are actually located in Asia. So we can see in here Japan, Singapore, uh, China, as well as India. The most adoption will be in Japan and Singapore. We can also see there UK and USA also having high adoption rate in lean construction. Okay, so this one is actually the principle of circular economy in a construction. We consider the design for longevity. We need to consider the durability and then adaptable structures and so on and so forth. And then the second one is design for the assembly. And then we also need to consider the material recovery and then regenerative sourcing. In Indonesia, we also find some of the production, some of the factory actually producing this bio-based material. One of them is actually material created from fungus. It's really interesting actually. And then the most important part is material passport. So this one is very important, particularly uh, in analyzing or calculating the numbers of embodied carbon in each material. So like in Yogyakarta province currently, they are facing difficulties in developing sort of library, I guess, yeah, library to for each material that has been used. So for example, if we are using cement, there are some option in the market, right? There are some cement with the green label as well as some cement without green label. So that's why if let's say we are using the green label, it will help us actually to analyze the embodied carbon of the material that has been used. So currently myself in a group of team in Universitas Gadjah Mada, we are helping the province of Yogyakarta to build this how to say the library, I guess we can call it as a library to list all of the material as well as to calculate to differentiate, sorry, as well as to differentiate the number of embodied carbon using the case, for example, utilizing the material with the green labels. So we would like to differentiate how many carbon we able to reduce when we are using the green label products or green label material. So that's why the material passport is really important for us to be able to calculate the embodied carbon in a product or in a material. Okay, let us continue. Okay, this one is actually a finding. I took this from the Global Status Report for Building and Construction 2024-2025 by UN Environmental Program. So we can see here, construction remains a key driver of the climate crisis. So the production of CO2 from the construction process is quite a lot. So we can see in here 21% of the global greenhouse gas emission is actually from buildings and construction. It's quite a lot, 21%. And then global waste produce, one third is from construction and only 1% reuse from demolition. So we can see that only 1% is actually implementing the concept of circular economy, whereby they are trying to close the circular loop in the circular economy principles. And then you can see in here as well, 18% of the global carbon emission coming from cement and steel, whereby they are actually responsible for 18% of global emission. So that's why we can see the urgency or the essence of the concept of lean construction, as well as the principle of circular economy, to be integrated in material innovation as well as selection to support the low carbon and sustainable construction. Okay, this one case and implementation. This is our research actually. So this research is a collaboration between UGM, ITS from Surabaya, ITB from Bandung, UTP from Malaysia, as well as Hadramaut University from Yemen. So we can see in here, Burisa also involved in our team back then when she was a student at UGM. So basically, we are curious. We want to know actually if we implement the concept of lean construction, how many embodied carbon or embodied energy can be reduced. So basically in this research, we analyze the EE, embodied energy, as well as embodied carbon. So the formula is actually similar. The differences is only the utilization of the index. So that's why we calculate or we analyze both embodied energy as well as embodied carbon from the material. Okay, so actually, yeah, like I previously mentioned, this is our curiosity actually. We want to know how many percent of embodied energy can be reduced utilizing the concept of lean construction. And then we can see in here, we actually also did some survey. We asked the AEC architecture, engineering, and construction practitioners about their decision criteria in selecting materials. So these are actually the top 4 criteria. The first one is durability. The second one is cost. And then the third one is embodied energy. And then the last one is the installation or construction. And then this one is our methodology. We are combining the qualitative and quantitative approach to be able to investigate number of embodied energy or embodied carbon can be reduced. Okay, so this one is the design of our case located in Bandung. And then these are the respondents for the first survey. And then we can see in here, we try to distinguish, we try to differentiate the perspective of architect as well as other than architects. So in here, we have planning, engineering, and construction consultants or practitioners. We can see actually both of the groups having similar thoughts on the priority when they prioritize uh, the decision criteria in selecting the material. So in here we can see for architect, they are actually selecting durability, prioritizing the durability. This one similar with the group from planning, engineering, and construction consultant. They also consider durability as a priority in selecting the material. Okay, and then this one is one of the material being looked at. And then this one is the methodology we are currently using. So we are using Revit. Inside the Revit, we can have a plugin like this one, CLC, Carbon Life Calculator. So basically, this one, we use this one to calculate the number of embodied carbon, and then we can also extract the data, and then we analyze or calculate the total embodied energy. And then this is the scenario. So we can see in here, scenario 1 is actually the common or general practice of construction. And then scenario 2 is implementing GIT. So we are actually limiting the study for the wall material. And then we can see in here that the volume is similar, and then there is a difference in the total material per delivery, because in GIT, like I mentioned previously, when we are implementing GIT, it means when the material coming to the site, it has to be directly installed or constructed. So that's why the number, the total material per delivery is different. And surprisingly, interestingly, the implementation of GIT able to reduce uh, about 3.7 total amount of embodied energy as well as the total cost. So we can see in the result, when we implement the GIT, we can reduce both the embodied energy as well as the total cost. Okay, so we also have another strategies. Oh, sorry. So basically this one is the continuation. So like ourselves as architect, we always face a challenge in making decision in design, particularly in deciding what kind of material we would like to have for our building. So this is the example. With similar case, we can see in here, if we would like to prioritize number of CO2 embodied carbon in a material, we will select concrete brick because the total embodied carbon is having the lowest, because the concrete brick having the lowest total embodied carbon. And then the second one, this one is actually based on the preferences of the decision makers. So in here we can see the decision criteria the decision criteria are risk, resilience, aesthetic, investment cost, as well as life cycle of material. We can see if, let's say, the architect or the decision makers having all of these decision criteria in selecting the material, the winner will be lightweight brick. So we can see in here there is a difference between prioritizing the total embodied carbon as well as prioritizing our preferences. And then the last one is preference about cost. We can see in here, if we want to prioritize the cost, it will be precast concrete panel. So it's kind of challenging as a decision maker. That's why in our next study, we try to develop a decision-making model to be able to incorporate all of these challenges, because we would like to have an optimized decision for selecting the material. And then this is another strategy. We also try to build awareness in our students in the program study of architecture at UGM. So we have a collaborative program, collaborative project. So the students, this one is collaboration with the UTP, University Technology Petronas from Malaysia. So we try to facilitate the student of architecture, collaborating with student of civil engineering, to design low carbon community facilities. So the session or the assignment or the collaboration work, in total the duration is 4 weeks. So these are actually the result from the collaboration between the students in architecture and civil engineering. And then this is one of the poster presented by the group. So we can see in here when they are designing the building, they also analyzing the embodied carbon produced from the construction as well as from the operation of the building itself. And then we also introduce to them about the concept of carbon sequestration, utilizing the green wall. So this is how we are trying to build awareness to our students. Okay, I think that's all. Thank you very much. I return the session back to the Madam Moderator.
Okay. Thank you very much, Dr. Yani, for your insightful and inspiring presentation. Ladies and gentlemen, now we will open the question and answer session, which will consist of 3 questions. Please. Yes, Burisa?
Oh, good. It's been a while.
Hi, Burisa.
Oh. Okay. All right. So, I have a kind of curiosity about one of the graphs that you have presented in your very insightful presentation today. It's the performance comparison of the lean implementation within countries, Japan, Singapore, UK, and etc. So I'm quite curious. From what I saw, Japan as one of the countries that has the highest adaptation rate only generate around 30% of waste production. While let's see, China has like the one of the lowest adoption rate within this graph. Also have like almost 30% of adoption rate. I think that from what I saw is that this line graph is not linear from the adoption rate to the waste reduction result. Do you have any information or insight to what's happening in here? Why the adoption rate is considered high, but the waste reduction considered low? Thank you.
Okay, very interesting question. Thank you, Burisa. Okay, so basically, I took this one from the research published by Agimian et al. So perhaps if I'm not mistakenly understood about the result, this one is actually highlighting the adoption rate as well as the waste reduction. So perhaps in a construction process, we can see that not the concept of lean construction as well as circular economy cannot be fully 100% implemented. Like in our previous study, yeah, we selected the wall because the volume is quite high. So that's why perhaps the number in here is resulted from uh, the how to say the implementation of the concept of the lean construction as well as the circular economy that cannot be implemented through to all of the materials in construction, because in a building we will have a construction material, and then there is also an architectural material and so on and so forth. So that's why perhaps only a particular material that currently can be managed to be tally with the concept of lean construction as well as circular economy. Any further discussion, Ibu Risa?
Um, yeah, so it means that it doesn't matter how high adoption rate being what to say conducted in the country, waste reduction remain kind of considered stagnant, right? It's because of one of the reason is material.
Yeah,
Is that so?
yeah, can be concluded as what you mentioned before. We can see that, like for example, if we would like to have value engineering in our design. We want to value engineer our design. Usually, we utilize the Pareto analysis to be able to see the 20% of the material that resulted to 80% and so on and so forth. Perhaps we can also try later in our study, perhaps in our future study, we can also integrate this one to be able to know or to be able to develop a model that can boost the reduction of the waste. But it's interesting as well, Ibu Risa. Yeah. Any further discussion?
I think that's good. Thank you very much.
Yeah. Thank you, Ibu Risa.
Okay, one more question.
Hi, Dr. Yani.
Hi, Dr. Wilson.
Hi. So, I would like to share, building on a very insightful keynote by Dr. Yani just now. I would like to share the implementations of BEAM and IBS in Kuching. So, imagine in a high-rise apartment or a large housing complex, project over 1 million in Malaysian currency. Here, BEAM and IBS are already at work. Yeah. So, state initiative in Sarawak weaving sustainable practices into approvals, and early adopters are showing that it can be done. So by 2030, yeah, we can envision roughly 30% of project in Kuching, Sarawak, embracing BEAM, building information modeling, and IBS. Yeah, mostly larger developments. Yeah, like planting seeds for a smarter, greener, and more confident construction industry. So ultimately, yeah, this story is not just about technology or policy. It's about the people's, the choices, and the visions that will shape the Kuching construction industry, Kuching skylines for generations to come. So, Dr. Yani, from your perspective, how do you see BEAM and IBS or prefabrications shaping sustainable construction in cities like Indonesia over the next decade?
Yeah. Thank you, Dr. Wilson. So thank you for sharing as well. It's a good news. I was in Sarawak perhaps 5 years ago, I guess. Sudah lama sangat. Okay, so related with your question about the utilization of prefabrication material as modular construction as well as the BIM, certainly it will help the country. For example, in here we are talking about Indonesia in reducing the carbon for sure. But what you mentioned previously, related with the human preferences, so this one becoming a big challenge in construction, because when we have an owner, and then actually in Indonesia we also have a marble, and then the owner want to import marble from other areas, so you can see the numbers of embodied carbon there. So that's why this has become the challenge. Not only the owner as well, the preferences of architect. So I notice in Malaysia there is also a policy, or there is also a strategy about IBS or modular construction, whereby the architect there can have modular, can utilize the modular material in their design. But in here, I think the architect they have their own preferences relating with the dimension. For example, dimension of the window, whereby we can reduce the waste by using the modular. But again, the the preferences become the big challenge. The concept is good, but yeah, the implementation facing one problem related to preferences. Thank you, Dr. Wilson.
Thank you so much, Dr. Yani, for sharing those insights. It gave us a lot to think. Thank you.
Thank you, Dr. Wilson.
Okay. Thank you, Dr. Yani, for your thoughtful and encouraging answers. It has been a truly engaging and eye-opening discussion. All right. And ladies and gentlemen, please give a big hand for Dr. Yani Ramawati. Okay, now we would like to invite Dr. Yani and everyone in the hall to join a virtual photo session together. Please get ready and smile for the camera. All right, so here we go. 1, 2, 3, go. Okay, one more time. 1, 2, 3, go. All right, thank you very much, Dr.
Thank you.
Yani Ramawati.
Thank you. Have a good day, everyone.
Okay, ladies and gentlemen, our final keynote speaker today is Insinyur Heri Prabowo, lecturer at Department of Architectural Engineering, Politeknik Negeri Pontianak, and PhD candidate in Civil Engineering at University Malaysia Sarawak. He holds a master's degree in Structural Engineering from Delft University of Technology, the Netherlands, and focuses on sustainable materials and geopolymer concrete technology. Today, he will present cutting-edge advancements in geopolymer technology, an emerging sustainable, eco-friendly materials for the construction industry. Please welcome Insinyur Heri Prabowo, joining us virtually from Malaysia. Hello.
Thank you, Ibu Arsanti.
Yeah, good day, Mr. Heri.
Good day.
Yeah, it's
I'm the
honor
last.
to have one of our distinguished lecture from Polnep closing today's keynote speaker. Yeah, I hope everything is going well in Kuching, Mr. Heri.
Yes, it's okay here.
Okay.
It's
Mr.
what is it? A hot weather, Dr. Wilson.
Okay. All right,
Uh,
Mr. Heri.
did you see my screen already?
Not yet.
Not yet. Sorry. Stop sharing. I have to close it first. Yes, yeah. What about now?
Not yet, sorry. Still working since.
Oh,
Okay, done.
sorry, still working?
Oh, not yet.
Not yet. What about now?
Okay, I think this is the screen sharing. Yeah. Yeah, already.
Yes, already.
All right, Mr. Harry, now the screen is yours.
Yeah, thank you. I'm lucky. I'm the last speaker in this dangerous time. Uh, Assalamualaikum. Good afternoon, ladies and gentlemen. Uh, I'd like to express my gratitude for this great opportunity to deliver a topic about the revolutionary construction industry. Uh, we are we are going to explore about the cutting edge development of the geopolymer technology, and it is a kind of paradigm shift from the our our biggest problem in environment to one promising solutions. And later, I think I will show you that the future of the construction industry is not merely depends on concrete, but yes, just like Dr. Wilson said, that it is a human factor also. It is a it is regarding also the consist. Well, my presentation will be cover key 7 key sections. The first section is regarding the context where it is necessary, and then the second section is about the geopolymers themselves, and we dive into the exciting cutting edge innovations, and we'll see also the application of the architecture and urban design. And also we talk about the environmental and the societal impact. And then next we will honest about the challenges and the future directions. And then finally, I will leave you with the call to actions. Let's dive into the first sections. We all know they are facing the climate emergency. As we know that the greenhouse effect now is stripping heat and lead to the extreme weather, and then also causing the degradation of our environment. And finally, it threats human life. Now, as a global citizen, we have to respond about this situation by like declaring this kind of emergency and try as we could that to mitigate the sustainable energy and try to adapt our infrastructure. But what is the correlation with this issue to the built environment? We can see here that the built environment contributing to 42% of the total global CO2 emissions. It is coming from the building operation and the building materials and infrastructure materials. The core, we can see that the core of this issue is coming from the material itself. And then we can trace back that the most problematic material is coming from cement. This kind of Portland cement is really nowadays as a backbone of our modern constructions, but it's really contribute to a massive carbon emitters. It accounts that around X% of the global CO2 emission is coming from this cement production. We can imagine that 1 ton of ordinary Portland cement it's equal to 1 ton of carbon dioxide released. So we really need the alternative binders beside these cements. Aside from the problematic material coming from cement, we also have other problem, which is waste. But this kind of problem, we still have opportunity to make it into a benefit for the eco-friendly binder, because it's will producing a lower energy and then give a stronger and more durable. If it can be succeed, if it is succeed, we can literally transform waste into resource, and then at the end we can turn it into the architecture itself. This is the comparison between the production of ordinary Portland cement and the geopolymer productions. We can see here that from the process of the ordinary Portland cement, 85% is coming from the kiln process. It's producing a kind of clinker that consume a lot of energy because it should be burned in a very high temperatures. So basically, cement production is really producing a high amount of energy, and at the end, it will contribute to a really high carbon emissions. It is different from the geopolymer productions. We see here that the project for geopolymer production is we can use the industrial waste like fly ash, for example, with the alkaline activator and then only silica grade. We just then mix it, and then we can cure it in the ambient temperature, and then that's it. That the geopolymer material is already formed. So geopolymer is a really promising material because it's using a kind of waste, and then also it's not really require a high amount of energy. We go dive into the understanding of the geopolymers. What is actually geopolymers? Geopolymers is comprising of two main materials. The first one is the precursors, and the second one is the activators. The precursors is the source of alumina and silica, and the activator is the source of alkali. And then these precursors can be coming from almost any kind of waste. The most used waste is a kind of agricultural and industrial waste. We can use this kind of waste alone or a mix of them. And then for the activator, we can find it from the sodium hydroxide and also the sodium silicate. And then a mix of this kind of precursors and the activator, we can form a kind of mix, and namely geopolymer concrete. And then if it is cured and then or open or cured in open temperature, we can also form a kind of stronger geopolymer concrete. From the very beginning, the geopolymer is actually really a kind of a chemistry process. This process includes the dissolution, condensation and the hardening or the curing process of the geopolymer. We can see that we just combine the precursors with the activators, and then we can get a free aluminosilica, and then it will harden when we cure at ambient temperature or even in the open temperature. We see also the sustainable source of the precursors. We see many ways, many type of ways that we can use for the precursors of the geopolymers. As we can see, the global trend of waste generation forecast for 2030 and 2050, we can see that the East Asia and the Pacific generating very high waste. And this kind of waste can be coming from a lot of type of field, like mining, agriculture, industry, wastewater treatment, construction, demolition, or kind of household, commercial, and government bodies. Yeah, actually, there is still much more type of waste. If we compare the ordinary Portland cement and the geopolymer, there's several parameters here that the energy consumption for the geopolymer is less than that is required by the ordinary Portland cements. And then we can also see the durability of the materials. So basically this geopolymer is really incredible, have an incredible compressive strength. It is as high as kind of high performance concrete. And then actually the unique properties is its high durability. It's also excellent to resist the fire, extreme high temperature, and also can resist the highly acid attack. You can see the highlights of the geopolymer performance here. We can see from the parameter of the compressive strength, it gives us a really high compressive strength of 149 megapascal. And then in the terms of temperature, it also oversee the counterparts, which is coming from the ordinary Portland cements. It shows the resistance over the high temperatures. And then if we see also the thermal conductivity, we can see from the RILAM standard that this kind of geopolymers can have an opportunity to be a kind of insulating materials here. And then we can see also the durability from the durability point of view, that this kind of geopolymer also have a very high durability properties. This is the graph that shows directly comparison between the geopolymer binder and also the ordinary Portland cements. You can see this, the carbon from the parameter of the carbon emission and the embodied energy. This kind of geopolymer shows consistency of 40 until 60% reduction in carbon dioxide emissions. This is most probably coming from the production effect, that the geopolymer binder have no kiln emissions, because it's really require a lot of high energy. We proceed with the cutting edge innovations. From the fundamentals, we go to the frontiers. We can see that geopolymers can converge with other technology like like AI-driven mixed design, 3D printing, and nanomaterials, and also give opportunity for collaboration with the circular system. And this is the vision for the building and construction 4.0. In the field of 3D printing revolutions, geopolymer really now can fabricate complex lightweight structures on site. It is kind of drastically reducing transport and waste. And this is not just an efficiency, but it's more likely like we get opportunity or possibility of generating new architectural that also incorporating the parametric and organic slopes that in the last time perhaps could be too costly or difficult to build. Researchers also making a kind of forest geopolymer structures in bearing in mind to make it a lightweight materials. Not only they can make it lightweight, but also they make it can capture and store carbon dioxide emissions by using the high surface area that coming from the porous materials, and then the storage of the carbon dioxide coming with low porosity and low permeability, and also the conversion of the light surface area. And then if we incorporating the nano materials in our geopolymers, it can still boost the strength of our geopolymer material up to 25%. This is a kind of nano reinforcement that we can also use for the geopolymer technology. It's very expensive nowadays that we use a kind of nano alumina, nano titanium, carbon nanotubes. And this is the scale range of the several materials that used during the concrete or geopolymer fabrications. And then we also lately or recently producing a kind of low alkalinity activation system, because in nature the geopolymer materials is really high in alkalinity, so it is not really good for the basal fiber. Basal fiber is usually used to concrete structures in the marine environment. This basal fiber is not really durable to resist this kind of high alkalinity. So it is a good start now to have a kind of low alkalinity activation system in as a type of our geopolymer. We can also optimize the mixed design of the geopolymer with the help of artificial intelligence. Now, to handle the complexity of parameters that includes in the design process of the mix, we can use the artificial intelligence, and especially in the neural networks architectures. It will be eliminate the costly trial and error testings. In the digital industrial design integration, we can combine this AI with the BIM or the LCA. We can obtain the holistic approach of these concepts. And then researchers also trying to be more futuristics. Like they also make a research on the regolith. Regolith is a kind of lunar soils that they try to make a perfect composition out of it, and they really do it, and it is successful. And this isn't just a science fiction, but perhaps later we can see that we have a need for vacation, perhaps to the Mars or the lunar. We need kind of active landing pads and habitats in there, and infrastructure, perhaps in Mars or Moon. The next section is the architecture and urban design. Now we can see the application of the geopolymer in the architecture and urban designs. Actually, the world's first geopolymer printed building is already become a reality in Las Vegas, Nevada, USA during the April 2023. Renshaw has already making his world's first 3D printed geopolymer building, which is already 2 years now. It's already a reality. We can also see the application of this geopolymer in the modular facade panels. It is not only beauty, but it is also the function of prefabricated facade panels, which is also suitable for insulation, like have a kind of unique properties for fire resistance, lightweight, and it can be produced off-site, and it will certainly accelerating the construction process. The other one is we can see the application in the load-bearing mud blocks. So we can also look back to the traditional techniques, which is using a mud as the construction materials, and then combining with the geopolymer, we can stabilize this ram art with a kind of more stable materials. We can create interlocking blocks with high strength and excellent resistance. We can also see the combination of ancient wisdom with the modern chemistry. We see here that Sibam in Yemen already have a this kind of earthly made structures, which is first it built in the 1530. It can reach 8-story buildings up to 30-meter heights. If we combine this kind of ancient technology with this geopolymer, it is can be a kind of marvelous collaboration of between the ancient and modern technologies. And it's also can producing a kind of affordable, sustainable housing. There is a lot of projects that have been generated. A project like Tofa House in Spain and Gaia House in Italy is a kind of not only a showcase of 3D printing with local and natural materials, but it also make a kind of sustainable housing more accessible. And this isn't just about being green, but it's about also the beauty. Also, we can upscale the regionalisms through the aesthetic potentials. This is a kind of ventilated facades by color board, 1.5 meter depth, that is produced from the geopolymer. We also can also use the local waste stream that can create unique colors. So every local materials can give its unique characteristic regarding the colors, textures, and also allowing for a new upcycle regionalisms, where material tells a story of place and identity. And in digital publication in architecture, we can see the stunning development with the means of parametric design with AI guided material models, and then also 3D printed organic forms, which is a kind of combination of structural and aesthetics. We can see also the urban integrations application, where we can scale this geopolymer technology to the urban level. We can imagine the city of future, which is also embodying the circular city concept, where our urban landscape is built from its own metabolized waste. As an architectural showcase, Global Chain Institutes in the University of Scotland was the world's first public building with structural geopolymer composites. It is built on August 29, 2013, and we can also see other case study, which is Al Wadi House in United Arab Emirates, that integrates geopolymer concrete with passive coolings. Regarding the environmental and societal impacts, we can still quantifying the benefits of the geopolymer again. It still consistently give us 40 or 60% carbon dioxide reductions, and then we have the opportunity to waste diverted from landfills into beneficial materials, and then we can also see the longer surface life of this kind of materials. From the life cycle assessment results that geopolymer have a lower embodied energy and less water use in its productions. And this material seems to build for longevity. It's really a material that can endlessly recycle, or kind of generating closed loop recycle endlessly. Not only the benefit for our environment, it is also social value creation that it can be produced by making a kind of geopolymer concrete. We can empowering the local people to have a local manufacturing and job creation, and then also communities through the green skills. This is aligned with the UN SDGs, especially SDG 9, that regarding the innovation, 11 the sustainable cities, 12 the responsible production, and also the 13 regarding the climate actions. For the climate resilient constructions, we can see this promising material can inherent resilience to fire, flood, and acids. That is make this material is really suitable for disaster-prone areas and for critical infrastructures like marine breakwaters, which is can protecting our communities in this kind of changing climates. And then we go to the challenges and the future directions. The path forward is not without a bounds. Masike Imaino said where there's no standard, that there can be no improvements. The limitation of the geopolymer concrete is the no global standard codes yet, because the material is very various and there is so many variability. And then also it is regarding the market perception challenges that we still face. It is about the humans. And then now the standardization progress is still working on progress by the active, sorry.
Oh, gentle reminder, you still have 2 minutes left to write.
All right. I think I can proceed more faster. Thank you. And then this is the smart and functional geopolymers. This is the other opportunity or possible application of this kind of geopolymers. And then we can also have a kind of a collaboration for change. It is not enough just to have a kind of brilliant idea or very good materials. We still have need to implement it or need to applications for this kind of materials. So these parties should be involved in this kind of boosting the this material, so it can be so it can be more it can be more used by the communities. These triple helix models incorporating the universities, the government, and also the industry business sectors. Demonstration of projects are the crucial catalyst that brings everyone together. Call to actions. And so we arrive at a choice. Like Dr. Wilson says that it is not only about the how good the material is, it is also the human factors. The future of construction is not just about concrete, it's about our concerns. It's about moving beyond just sustaining our planet to actively regenerating it. And then as a key takeaways, this kind of dynamic relationship between the innovation, integration, and implementation with embedded evaluation is really important to boost to make this kind of innovation fastly used by our communities. And then this is, I think, the end of my sessions. Thank you for your time and attention. And then as the final quote, that I want to say that the future is not something we enter, it's something we build. And I believe together we can build a better one. Thank you. I hand over this session to the moderator.
Okay, thank you very much, Mr. Harry, for your insightful and inspiring presentation. Ladies and gentlemen, please give a big applause for Mr. Harry. Okay, now let's move to question and answer session. I open the question for on-site and online participants. Please raise your hand on-site. Okay. Burisa, please.
You for the opportunity. Hello, Harry. How are you doing?
Hi, Burisa.
Yeah, it was really an interesting presentation that you presented to us today. So I'm quite curious about because I'm focusing on the common thermal properties in materials. I want to
Yeah.
know, do you have any insight about what if we apply that geopolymer in tropical countries like Indonesia? Will it face any challenge? Let's say if the material is too hot or not too hot. I mean, like if the material is not good enough in reducing this sun radiation, the heat, like the challenge that we actually face in tropical countries.
That's it. All right. This kind of material is really actually really good at high temperature situations or conditions. But for the thermal properties, each materials, it basic materials is really different from each other. So that's the problem of this kind of geopolymers is very unique. It's very unique. For every basic materials, it will be a resulting a kind of different properties also. So we have to know which kind of basic materials that appropriate for or suitable for the application of the certain like buildings application or like that. But obviously it can be done.
Yeah. So, what do you think is the most challenging?
The most challenging of what?
Uh,
Of this kind of materials.
I mean, like, what is actually the most challenging in applying that material in Indonesia, or it's actually have been applied?
No, it is not. It is still not applied in Indonesia. I think it's in the stage of research or in the lab level. I think, but I think Indonesia is a really potential for adopting this kind of materials because we have very various and also abundance basic materials in Indonesia. We can use waste, and then also we can use our natural resources that they're really numerous.
Okay, Lisa, is it clear now? Yes, okay. All right, Mr. Harry, we have one question from online participant from Aulia Maula Al-Qadri. The question is, thank you for your insightful presentation, Dr. Candidate Hari. I am Aulia Al-Qadri with a research interest also in materials and architecture, specifically in how physical properties influence material behavior or the ability to retain or adapt to them. My question is, considering to your research on sustainable and eco-friendly material, what has been most challenging aspect in testing or evaluating the performance of these new materials, particularly in ensuring their reliability and consistency over time?
Yeah, these good and interesting questions. In the experiment stage, we can optimize this kind of material by using a kind of design experiments. I do my this kind of experiment for my research using the rice husk S by using optimization process using the response surface methodology. So it is really not easy, but still it's still achievable. I think it is not easy, but it is achievable. But if you playing a lot with this kind of material, we can you will understood this what is it, the unique properties, the basic unique properties of this kind of materials. It really helps you a lot.
Okay, Aulia, what do you think? Let's see now.
No, thank you.
Okay. Oh, yeah, we have our last question from Dr. Rosia here. She said that investing architecture made. Is this something that can be used for self-help construction?
Yes, of course. We can do it by ourselves with our surroundings materials. I think it is not a kind of for a simple use like what is it, building materials, like we can produce a kind of our own bricks. Perhaps we can use our surrounding materials coming from waste even. It's really locally available materials.
Okay, then, thank you.
Okay. Thank you, Mr. Harry, for
Yeah,
your helpful and encouraging answers. Uh, now, ladies and gentlemen, please give a round of applause for our last keynote speaker, Senior Harry Prabowo. Okay, once again, I invite all the participants, both on-site and online, to open the camera and give your big smile for documentation team. Okay. All right, we start in 1, 2, 3. Okay, 1, 2, 3, go. One more time. 1, 2, 3, go. Thank you very much, Mr. Harry. Ladies and gentlemen, before we officially close this keynote session, we would like to invite our distinguished speakers to share a few closing remarks, a brief reflection or final message for our participants here at ICArUS 2025. We begin with Dr. Abdul Muin Bugis, followed by Surveyor Dr. Wilson Rangga, Dr. Rosia Haji Adenan, Dr. Yani Rahmawati, and finally, Insinyur Harry Prabowo. Each speaker may take about 1 or 2 minutes to share their concluding statement. Okay, Dr. Bugis, would you please start with your closing statement?
I again, I would like to thank you guys for the attention and bearing with the technical issue I got at the beginning. I hope the presentation has contributed to the meaningful insights to this conference. I really enjoyed that. At least I was the only maybe landscape architects here among the architects and planners here. And so that's a good representation. And I wish that we see more invitation for other landscape architects and see more contribution in this field. I look forward for any future opportunities for collaboration, engagement in this field of resilient infrastructure. It's a topic that has been really taking place in research and implementation, and it's a serious action and changes happening across the world, and I feel like it's time to make this change in our curriculum, in our policies. Hopefully one day, like I'm considering also relocating to Malaysia and Indonesia, since I'm originally like from Malaysia. I do not speak Bahasa, by the way, but I'd be pleased to connect with and continue this conversation. You guys have my contact. If you don't, please reach out to the organizers. They can give you my contact. And thank you again for hosting me and inviting me. This is my second time as a keynote speaker, and I'm so honored. And terima kasih to everyone.
Okay, thank you, Dr. Abdul Muin. Next, we would like to hear a few words from Surveyor Dr. Wilson Rangga to share his closing remarks. Please, Dr. Wilson.
Thank you. Okay, as we wrap up, I'd like to leave you with this thought. The most important materials in sustainable construction isn't steel, isn't concrete or glass. Yeah, it's human intentions. If we align knowledge, behavior, and responsibility, innovations will follow naturally. Looking ahead, the real power lies in future collaborations across disciplines, across generations and regions, where architects, engineers, policymakers, and community works together. And let me also take a moment to thank the organizers for inviting me as a keynote speaker. It's an honor to share these platforms with such inspiring minds. And let's continue building not just structure, but communities, legacies, and partnerships we can all be proud of. Okay, so thank you.
All right, thank you very much, Dr. Wilson. Now, we kindly invite Dr. Rosia binti Haji Adnan. Please, Dr. Rosia.
Yes, thank you very much. First of all, I'll give my thank you first. Thank you, everyone, and thank you for
Sorry,
inviting
Doctor.
me. Hello?
We cannot hear your voice here.
Can you hear me? Can you hear me now? Can you hear me now?
Yes.
Okay, good. Okay, sorry, the mic. Okay, so first of all, I want to thank ICArUS for inviting me. I'm so lucky to have my first ever keynote speech talk here. So everybody's been so lovely and so kind. So thank you very much. I think my parting note would be as much as we can connect on the social side, we make connections in that way. We still need to have more structured infrastructure and research representation as well. So today I met all the keynote speakers are definitely contributing to that. So in a sense, we can all contribute, not just on the academic or research level or tertiary level, but even everybody who is involved in any of the works that we do can contribute as well.
To all sorts of information, try to make a picture together or some kind of project together, and that goes with the collaboration, of course. Thank you very much.
All right. Thank you, Dr. Rosia. Next, we move to Dr. Yani Ramawati from Universitas Gadjah Mada. Please.
Okay, thank you, Madam Moderator, for the opportunity. I would like to thank to the committee for this opportunity, giving me the opportunity to talk as a keynote speaker in this conference, hopefully beneficial for all of us. And then I would like to second the statement given by previous speakers that collaboration is important. With that, I would like to invite perhaps some of you having interest in building awareness, particularly for our students, architect, civil engineer, or other discipline about the about to develop more sustainable future from our design and so on and so forth. So that's why if let's say you are interested, please don't hesitate to contact. And then the next one, I would also like to invite if all of you are or some of you are interested in having a collaboration in a research related with the embodied carbon calculation or analysis, because I noticed some of the area, state or province, they are also struggling in analyzing the embodied carbon in their process as well as product. That's all. Thank you, Madam Moderator, and thanks to all. Good day.
Okay, well done. Thank you very much, Dr. Yani Ramawati. And finally, we would like to invite Engineer Heri Prabowo to deliver his closing remarks. Please.
Thank you, Bu Arsanti, for the opportunity. I think I'm the only one coming from the civil engineering background. I think in the middle of the architects, I feel one sentence. I feel really honored, and I already gained a lot of insightful and fruitful experience, and also in perspective from you all. I'm not. I can wait. Looking forward for the collaborations. Thank you.
Okay. Now, ladies and gentlemen, that concludes our keynote presentation for today's conference. On behalf of the organizing committee, I would like to extend our deepest gratitude to all our keynote speakers, Dr. Muin Bogis, Surveyor Dr. Wilson Rangga Anak Antoni Jiram, Dr. Rozia Haji Adenan, Dr. Dr. Yani Ramawati, and Insinyur Heri Prabowo for sharing their knowledge and expertise with us virtually. We also thanks all participants here in the hall and online for your attention and active participation during the question and answer discussion. Now, to continue with the next agenda, I would like to hand the session back to our Master of Ceremony, who will guide us through the following program. Thank you very much, and please give another warm round of applause to all our keynote speakers.
Thank you very much to our moderator and our keynote speaker for the insightful and inspiring session. We truly appreciate your participation and attention throughout this keynote session. Now we will have a break for lunch and prayer. Please enjoy the meal that has been prepared and take this time to refresh and network with fellow participants. After the break, we will proceed with the parallel session according to the schedule. Kindly check your assigned rooms and session information on the conference program. Big room 1 in accounting hall, big room 2 offline session in Mahameru. Thank you and enjoy your lunch break.
Thank you, everyone. Have a good day.
You have
Thank
a
you.
good day to Dr.
Bye.
Yani,
Thank
Dr.
you.
Wilson, Dr. Rozia.
Sini ya. Kedengaran nggak sama suara bicara? Halo? Halo? Ada ya suara ya suara. Halo? Kan nggak pakai mic ya di sini ya, Pak? Nggak pakai mic. Enggak ada alat. Enggak kedengeran nggak? Sana enggak ada ya. Baterainya gimana tuh, Pak? Ya, biar coba keren. Izinnya panggilan juga bisa masuk. Ya, izin masuk. Coba saya join sebentar. Oke, saya. Iya, nyampe suaranya. Kayaknya nyampe di online. Cek 1 2 3. Oke nih.
Hello? Yes. Yes.
Tes, tes. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to the parallel session of the International Conference on Architecture, Urban Design, and Settlement, ICArUS, hosted by the Department of Architecture, Politeknik Negeri Pontianak. My name is Fiska Hidayat, and it's my honor to serve as the moderator for this session. In this session, we will listen to presentation from our distinguished speakers who will share their insight and research related to theme innovation, sustainable design, and materials. Tes, tes. Tes, tes. Tes, 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 tes. Tes.
Minta banyak gambar kerja Bapak.
Cuma arsitektur.
behalf of the organizing committee to express our deepest gratitude to all distinguished speakers, moderators, and participants for your active contribution throughout the session. Before we end this event, I'll announce the best abstract from the two parallel sessions. Room 1, Mr. Puspito Harimurti. Give applause, please. For room 2, Miss Aulia Maula Al-Qadri. Congratulations to the winner and thank you to all presenters for your great contribution. Today has been filled with inspiring presentation, insightful discussions, and meaningful exchange that truly reflect the spirit of collaboration and innovation that this conference upholds. We also extend our sincere appreciation to our partners, sponsors, and organizing team for their hard work and dedication in making this event a success. We hope that the ideas and connection you gained here will continue to grow into future collaboration and research opportunities. Once again, thank you for being part of International Conference of Architecture, Urban Design, and Settlement, hosted by the Department of Architecture, Politeknik Negeri Pontianak, Indonesia. Riak kapuas beralun lembut. Sampan melaju perlahan pergi. Budi dan bahasa tetap terpaut. Terima kasih dari kami di sini. Assalamualaikum warahmatullahi wabarakatuh. Thank you and see you at the next ICArUS conference.
Segera Bapak Ibu, silakan maju ke depan. Silakan kita berfoto bersama. Ya, silakan Bapak Ibu dosen, silakan. Pak Tommy, silakan. Setelah ini kita bersama mahasiswa ya. Bapak Renaldi Abdul Halid, Pak Yudiarma, Pak Nurdin, Pak Nurdin Abu Bakar, Pak Indrayadi, Pak Tommy,
yang punya titel Bapak ke depan.
Silakan Bapak Ibu mahasiswa